Yeah.
Sir, actually, I'm facing problems in the pseudocodes which involve the Boolean values like true or false. In many questions, I'm getting confused.
Can you give me one or two examples so that we can look at those questions particularly, so that
Yes, sir, I'm just
Mm.
give me a
Yeah,
few
yeah, sure,
minutes
sure.
and
Take your
I'll tell
time.
you.
Yeah.
Like yesterday, also in the mock test, there was one question related to that.
Mm-hmm.
So there was confusion in that also. Actually, sir
Mm-hmm.
was explaining very well, but still, I
Yeah.
mean,
I know sometimes the truth tables can be a little confusing, because when we say something, we want
he
this
was
not to be
explaining quite
true. Mm.
elaborately that,
Mm.
there was no, uh, he was trying his best, and
Yeah. How do you
many
approach such
children,
questions when you have?
many students were
Mm.
able to understand, but I don't know why I get confused in such types of questions.
Yeah. No, what usually issue is that, right? Give me an example. Suppose, if I say not, suppose, we want to see whether, so yeah, just give me an example, then I can,
Yeah, it is
elaborate it to you.
one example is there,
Uh,
graded assignment 4. There's the last question of that assignment.
Your assignment 4,
The
last
last
question.
questions.
Okay.
I think I actually previously asked one of the TAs also,
Mm-hmm.
Rishita ma'am, but she
Mm-hmm.
also explained very well.
Yeah, no, the
Um,
thing with the Boolean values, right, in pseudocode, usually you
mm,
use it for testing purpose, right? You
mhm,
want in a test statement. So if you want to know whether something is true or false, given that condition, suppose I say, if something is true, do something,
mm.
right? Or we usually ask a question, if something is false, then do something for me.
Mhm.
Sir, I have recently joined this meeting. What is going on?
This is a Q&A session. So whichever question you have, just let me know and we can discuss those. So what's your name?
Sunita.
Yeah. So Sunita, what you really need to understand, right? At the end of the day, you need to analyze the statement, whatever is in the if block, right? And you
Mhm,
want to get the value, whether it is true or false. So you may encounter a very complicated scenario where you may be, comparing a value. Suppose I can also say if var is equal to 2, and say, suppose I'm saying and is key is something, some argument is there, right? So
mm.
in this scenario, what you're saying that and only operates when both the conditions are true, right?
Yes, yes.
So only when this is true, the
Mm.
and will be true.
Mhm.
And so
Yes.
the if block, like whatever it is, right? So in if statement, at the end of the day, you just want to see if this is true or not. If this is true, then you need to do something for me. If that is false, then you do something else for me.
Mhm,
So in this scenario, the way I approach usually the problem is that
mhm,
if it gets too complicated, if statement is really long, I'll just break down into smaller chunks. So I'll just say, okay, this is one test condition, this is another test condition, and this is another test condition, and itself is another test condition. I can also have an or operation here,
mhm,
right? In case of or, either can be true, right? Not necessarily first has to be true. So in
mhm.
this scenario, like what or operation eventually will give you, if either one of it is true,
Your
the
voice
whole
is
statement will
breaking,
be
sir.
true. Hello, is it breaking for everyone?
No,
No,
sir.
sir, it's okay.
No, sir, it's clear.
Yeah. So what
In
use?
the three conditions, it will give true only. When true or false, false and true, and true and true. In all these three conditions, it will give true.
Yeah. So what you really need to break it down is, instead of this, you just put it true. Instead of this, you just put it false or true, something of that sort, and then assess the whole equation such that whatever condition which is in the if block turns out to be true. Only then whatever is inside the conditional, right, will be executed. The other time when we use it, right, we usually initiate it. Suppose var is equal to true or var is equal to false is what how we initialize it, depending upon what condition we want to test. So this is really, you want to see, why something is being initiated the way it is initiated, what it is that you're testing inside a loop, and when you're making this statement to be true, are you counting something, are you adding something, or you're doing some other manipulation?
Like suppose we have initialized something, so that in the pseudocode that will also be given na, that the finally what we want is true, or we want what we want is false. That will be coded inside the pseudocode only na. It is not necessary that whatever the value has been initialized, ultimately that will only come at the end of the pseudocode. What the pseudocode wants, it will be given inside, that it wants it to be true or it wants it to be false. That is acceptable. That will be given in the pseudocode only.
Yeah, so the pseudocode, the purpose of any of the Boolean value is to make sure that certain condition is being true, such that when you use that inside a if loop, you can use it for something else. Suppose for this particular condition, so suppose I said this var 2 is my new variable and it is I am initiating to be false, and suppose I am I'm testing whether if just var is equal to an age key of some dictionary, right, then I would say okay, then you just make the var2 is equal to true, and maybe that is what I am using in some other loop. Only when it is true, do something onto it. So this is usually how the Boolean variables are being used, is to initiate some other conditional stuff. So whenever you see something being initialized like this in your pseudocode, right, just remember for what purpose this Boolean value is being used. Is it being used for iteration purpose, filtering purpose, or maybe summing purpose, summing under certain condition, right? You have seen in your first 4 week itself, right? This Boolean variable is used so often to do some set of counting. Finding max, min, or something of that sort. They have used this Boolean variable very cleverly. So just don't, whenever you see it, just don't freak out. What you should do is, just look at its purpose. Where it is in the pseudocode is, it is being used, and for what purpose it is being used. Usually what happened that we usually go by, line by line. Any of the pseudocode, we will try to go line by line. Just look, screen it, okay, something is being declared, okay, something is being tested, then something is being counted. Then you look at it, okay, what condition they are using it for, filtering purpose or counting purpose or finding min max purpose, or even for sorting. Suppose you want to sort based on some conditional, that also you can use. So if you give me an example, I can explain how a particular
one example is this, which I told you.
Graded assignment, last question, right?
One or two I'll give you just in a few. Just a minute.
Yeah. So what I will do is I'll share on the screen.
So will this be only a doubt clearing session for the entire class?
Yes.
Doubts by 5:30 or something.
Sorry?
Should I just ask me later on? Because if it's only a doubt clearing class, I'll ask it later.
Yeah. This is just a Q&A session. So if you have doubt, stay. We can discuss those. If you don't, then it's up to you.
Graded assignment 10, question number 9 and 10.
Just a minute. Give me a second. Is my screen visible? Okay. Just.
Sir, in mock test.
So what was the previous question which was asked, sir?
She had a doubt in. Just give me a second. Yeah. So it was graded assignment 4, right? Last question. Yeah, the question was how usually this Boolean.
Okay, sir. I think I don't have any doubts in it.
Yeah. So that was what the question was. So she was not sure how it is being used and for what purpose it is being used. So this is the one, right? Graded assignment 4. This question?
Sir, I don't have any doubts in it.
No, I think Sunita
yes,
had
yes,
question.
yes,
Yeah.
yes. Sir.
Yeah. So yeah. So take a look at this example, right? The following pseudocode is executed using words dataset. Okay. So what does word dataset has? What all? Just a minute. Yeah. So you have two variables. Okay. The way I will look at it, right? Okay. There are a bunch of variables a, b, p, and q. Two of them are initialized as an integer value. Two of them are initialized as a Boolean values, where p is true and q is initialized as false. Okay. Then while is what it does? While loop. It is iterating over all the data, right?
Iterating.
So this is an iterator. Okay. Now in iterator, what we are iterating over? Okay, we are iterating over rows, and we are trying to find some part of that particular row, and we are comparing that, right? So there you see in two of the if statements, right? This is now conditional. Based on this condition, we are trying to do something. So we have p here, right? Now in this particular scenario, x dot part of speech is equal to adjective and p. So what do you think?
What does this and p stand for? And p.
So like I said, right, x dot part of speech is equal to adjective. This you understand, right?
Yeah.
So if the part of speech feature of this particular row is adjective, if this is true, and if p is true, so and option operation, when it happens, when both of them are true, right, only then it will enter into the code. Correct.
Yes.
So if this is true,
Sorry, if
p is
both are
already
false,
initialized to true. Sorry,
if both are false, then it is also working.
both are false. Suppose if I say this is false and p is also false, will it get into this?
No.
Can you tell me the truth table? Let's look at that first. Just a minute.
Yeah, yesterday also like sir drew a table. So it's always like that we need to draw a table for these
No,
kind of
truth table is for you to know the condition.
Okay.
When it is true and when it is false.
False, yeah.
Right. When you have an AND operation, when you have an OR operation, under what AND operation the conditions becomes true, under OR operation when it becomes true.
Okay.
This is what you want to make sure that, because this is only the AND is operating on these two conditions. Only when these two are true, it will become true. And if will, so at the end of the day, if something is true, it will, get into the
If
this is this conditional. Otherwise it will not get. So for what purpose, for what AND table this will become true is what you should ask.
Okay.
So just give me an example. I'll just share one more screen. Yeah, so yeah, tell me, you said, right, when both. So yeah, I'll just ask you people, you just tell me for AND operation, right?
There is truth table, sir, not truth table.
For, yeah, suppose you're testing for A and B and A or B. Okay. Sorry. Just give me a minute. It just got frozen. A minute, I think the app just crashed.
Yeah, okay, sir.
Sir,
Yeah, yeah.
can you sort?
Sorry. Hello. Yeah, Naman. Am I audible?
Yes, sir.
Yeah. What was your query?
So I wanted to convey that may I please ask my doubt after Sunita's doubt is clear?
Yeah, sure. What's
Yes.
your doubt? I'll just list it out.
So during the week 9 and week 10, we were introduced to matrices. So I was facing a problem like how to go to the graphs when we are given information related to dictionaries. For example, in practice assignment of week 9, the question 2 and 4.
Practice assignment.
Week 9, question 2.
Question 2 and 4. Huh?
Yes, sir.
Okay. Yeah. Any other doubt? You guys can tell. Meanwhile,
Sir,
it gets restarted, right?
Sir, I had gotten practice assignment week 7. Just a minute, sir. I'm just taking out that question.
Meant week 7.
It's a practice assignment week 7.
Question?
1 and there's a continuation question, sir.
Yeah, 1 and 2, is it? Or it has only one question?
No, sir, 1, 3. Sir, I think I'm looking at the wrong assignment.
Okay.
Sir,
The practice assignment week 7, 1 and 4.
Practice assignment?
Week 7, 1 and 4.
sir, I have doubt in mock for in term question number 13.
No, just a minute. Question number 1 and 4. Week?
Practice assignment week 7.
Week 7. Okay. Yeah. Next, who was it?
My doubt is from mock for in term question number 13.
Okay. Yeah. So, yeah.
And also last and practice assignment 8, question 1.
Sorry?
Practice assignment 8, question 1.
Yes. Question number 1.
Then one last practice assignment level 11. So question 3 is it's a continuation question. So if you could explain, I can answer the remaining. Question 3, 4, 5, 6, 7 are from the same pseudocode. If you explain the pseudocode, I can answer.
Okay. Practice assignment 11, right?
Yes, sir. So the 3, the pseudocode of 3, 4, 5, 6.
Okay. Yeah.
Sir, I have a doubt in end term, question 22.
Okay.
Hello, sir. Please take my questions with respect to assignment, graded assignment 11, sir. Sir, it is from question number 8 to 11. It is related to single, this question. It has 4 parts.
Okay.
8 to 11.
Okay. Question number 8 to 11.
Thank you, sir.
So 7, 8, 11, and mock questions is what you have questions in. Okay. Yeah. So yeah, somebody was saying something about the truth tables. Just quickly, we will go through this. Okay. Yeah. Yeah. So truth table, you tell me when A, B, what should be the condition if, so suppose when A is true and B is true, what should be the condition for this, this particular?
True.
It
True,
should be
sir.
true. Okay. So if A is false, sorry, B is true, the
False.
condition should be
False.
Then
false.
false.
Okay.
False.
So if it is true, if it is false, it is
False.
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 If it is false, and if it is false, it
False.
is
False.
false,
False.
right? Somebody said it is true, so that's why I asked you. Okay. Now you tell me what about this OR operation. When A is true and B is true, the condition is
True.
True.
when A is true and B is false.
True.
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 When A is false and sorry,
True.
it's true. This is
True.
true.
Yes.
And what
True,
if
true.
both are false?
Then false.
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 False, right? So when you look at your question, right? When you look at any of your questions, what it is telling you, whether when this is true, the AND operation will give you what? True, right?
Yes.
Only in that condition it is true. Everywhere else it is false.
False.
Similarly true, similar with this statement also. Unless and until you had an OR, then you had an option that 3 of the instances it could have been true. So you really have to break down this question into 2 parts, 3 parts basically. Look at this condition, look at this condition, look at what and this operation means, and then you see that it is you are flipping the values, right? Now P becomes false and Q becomes true.
Yeah.
Now where this is being used when this is flipped, right? Then you can clearly see that in the very next if part it is being used and it is counting something, right? So it is counting B. So what is B? B initialize you to 0. So whenever it is noun and when this condition is true, right? When it is
Suppose, sir, if in the if condition where adjective and P is given, under that, if we enter that, it is written P as false and Q as true. Suppose it would have been given P as false only and Q would have been false. And in the next sentence, it is given X dot part of speech as noun and Q. Then we would have considered Q as true only or false.
See, if once this if block is over, right, it will go into the next statement. So whatever flip you have done in here will be applicable for this entirety of the while loop.
Okay.
Right. This is one big block under which you have this one block, then another block is this, another block is else block. You have this if block, it starts from here till here. So you have a sub block of else for this if statement. And then another if statement is there. So there are 3 blocks, 1, 2, 3 blocks.
Yeah.
Under this one block. So for each of the block, what is happening with the variables is what you should see. That's why
Sir, I have
when
doubt. So here and P and Q, what is this indicating? And P means whatever the value of P from the back, it takes the true, only true, not false.
No, in the first iteration, right, P is set to true, right? Suppose
sir.
now in this particular scenario, P has been true. You have a condition where adjust there is also a true condition. Then P becomes false. Then this entirety of the block, your P will be false until this condition is met. Otherwise, it will remain false even for the next iteration. Understood? For the next iteration, it will not again set to be true till this whole while loop is executed. Whatever is happening inside the loop, right? Whatever happening to your variable will remain true till all of the rows are exhausted. So when you flip it here, the P to the false, for the entirety of the while loop till P becomes true, will be false. Am I clear
Okay.
or
Okay, sir.
Yes, sir. Yes.
understood? So when you look at the pseudocode, don't just look at statement by statement. Look at also block by block. What is happening to your variable? Assess that and see for what purpose you are testing it for. This will really makes it easy to visualize the code. What is happening exactly inside it? Okay. Sunita, is your doubt clear or should I elaborate more?
Sir, it is clear. I mean,
See, for this particular question, right, you see that
mhm,
P and Q has been initialized for certain purpose.
mhm,
The purpose was, you wanted to count something. True? You wanted to
mhm.
count B. B is only counted only when you
There's a
have part of
noun.
speech
Yeah.
is equal to noun,
Hmm.
right? And
Yeah.
your A is counted only when Q is what? True or false,
False.
right? Not
Hmm.
Q means, not false
False.
means true, correct? So only when
Hmm.
Q is true, this will also increment.
Hmm.
So you see that, you have counters going on for this particular if this Boolean variable initialized,
Hmm.
right? So this is the reason mostly these Boolean variables are used is for this purpose. Like in this particular scenario, you can see the moment word is ending with a full stop, you want to again switch it to what original values
Yeah, the initial
were,
value.
right? So after each of the statement,
Hmm.
just by looking at it, you can say that after each of the statement, this is reset to what it was initially. Again, for each of the condition, it will keep on iterating through all of this if loops as and when these
Hmm.
conditions are met,
Okay.
right?
Okay, sir.
So when you think like the reason why they are little complicated is that for this example, right, not Q, it is not very intuitive. Like right away you won't understand, okay, what does it mean by not Q?
Hmm.
So you may say, okay, when Q is not true,
Hmm.
right? That is what it is, right?
Yeah.
So instead of looking intuition wise, just put the value and you know what not means,
Hmm.
right? And you know what condition has, whatever the condition which is inside this particular parenthesis has to be true for it to enter into the if block.
Hmm.
So if you break it down, then you will realize, okay, how it is being used. And the more you will practice it with pen and paper, you will realize, okay, what is happening at each of the flips, each
Yeah,
of the
that's what
block.
the TA also told me that if you practice 4 to 5 questions of such type, you will be able to get the next.
Realize that. Just,
Mm.
but the important part here is that you really have to jot it down till you get a clarity of what actually is being tested, because this is not very intuitive. This is not what we encounter in our daily routine life, right? We never talk, okay, you not do this thing doesn't
Mhm.
necessarily mean that you have to do this thing.
Yeah.
So it becomes a little complicated. So it's always better if you just put all the conditions here and see what each of the block is doing. In exam also, this practice will really help you while solving the questions. Look,
Okay.
just go through whole code, see what is being initialized, what is being counted, just take a
Mhm.
note of it, then look at all the blocks, and then you look at the question, okay, what is being asked or what is there in your options. Then you will realize, okay, what is happening, even without going line by line through whole code. Okay.
Okay, sir. Yeah,
Okay, so
thank you, sir.
let's go to week 7, right? Week 7, question 1 and 3. Week 7.
Sir, can you show the
Yeah.
answer of this question which you are showing now?
Yeah. Number of words which appear before the first adjective in every sentence. Do you want me to go through all of this?
No,
Because
I
if
just
you,
want to see the answer.
yeah. This is the answer for A. For B, it is the number of nouns out of the first adjective in every sentence. That is what A and B is counting. Okay, should I move? Graded assignment 7. No, practice assignment 7, right? Question 1 and 3, was it? Yeah, what was the query in this question? Hello? Hello, am I audible?
Yes, sir, you are audible, sir.
Yeah,
Yes,
whose
sir,
question was it?
audible, sir.
Sir, it was
1
my
and
question.
yeah, so just tell me what was your question query in this question. So we'll start from there. The following pseudocode is executed using scores dataset. What will be represented at the end of the execution? So again, you have an empty dictionary initiated, then you have an iterator which is iterating over something. You have some if condition which is checking over your dictionary. Then you have an if condition which is going through your rows, looking at certain information, and it is entering that value into your dictionary. Otherwise, if this condition is not true, it is entering something into it, and then the row is being iterated. And then after this, what you have A is equal to 0, B is equal to an empty list for each key in D. So okay, so it is updating some, what do you call it?
Sir, I
Use
have
the list.
understood it is the list of
List.
physics marks, but how do we know it is the highest physics mark? Like from the
It
options,
is
we can anyways
comparing the
find them.
D of key greater than A in that line number 20.
So you said what? The list of cities. Okay, just look at the options. Okay, so you have number of cities or you have list of cities, right? Either it is number of cities
That
from
I've
which.
understood, sir, because it is talking about the list B is key, but how do we go to the highest physics marks if you can explain?
Okay, what B represents? Okay, it's definitely a list because you already know it is initialized
Yes.
as a list. List of cities from which students have scored highest physics mark. List of cities from which students have scored same marks in physics. So when is your B, what do you call it? Modified?
When D of key is greater than A, then B is
No, for
updated.
each key in D. So D is your direct
In line number 20.
dictionary. Yeah, in line number 20, if D of key is greater than A is equal to
And
D
A
of
stored the
key.
maximum marks in physics.
Yeah, so so the value for A. Let's look at this. What keys of D will give you?
City, town.
No. Keys of D will give you a list, right?
Yeah, yes, sir.
Yes, a list of city.
List of what? Cities.
City or town. Yes, sir.
Okay, so if
Not
you look
city
at,
or town, from
Yes,
which the
sir.
students.
So if you look at
cities
it,
of the
right?
students, sir. Like,
just look at this. Okay, your D is initialized as a dictionary. Then you going through each of the rows in the
so
table.
what is the fourth line represent? I'll just say my doubts if this code fourth line.
Yeah, so in fourth line, right? What is key will tell you.
So that I know. So what is D comma extra city town?
Yeah, so city / town. So this is an entirely one thing. Okay, these are not two separate things.
Yes, sir. Like it's
Yeah.
a city of town from which the students have scored or what city?
So if D, so currently, so for the first row, right? Let's look at one by one. Okay, the first row D is empty, right? So what it is asking if this particular key is present in the dictionary or not, right? If it is present, only then it is going inside, right?
Yes, sir.
Right? If because each key gives you true or false, right?
Yes, sir.
So each key function gives you true or false condition. If this is true, only then it will go inside. If this is false, where it will go? It will go into else statement. What is it doing in the else statement? It is adding x dot city
Yes.
slash town as a key, and it is adding the
Physics.
value as x dot physics mark. Correct?
Yes, sir.
So this is clear, right? City town is your key, and the marks are in your values. So again,
So what is D of x dot city town represent? Like, can you just go back to the scores data set?
so x dot city or town. Just give me a minute.
Like, it's a city or town of the student of what?
Just a minute. Yeah. Yeah, but this is clear, right, to you?
Yes, sir. Clear.
Yeah. So you know the way we add values to a dictionary
I
is
think
by
after
this
that the
method.
code is clear.
Yeah. So if you check this,
Yes, sir, it's clear after this.
Scores data set, right?
Yes, sir.
So if you look at the scores data set, what your city town represents, it tells you the name of the city, right? Hello?
Yes, sir. So I just want to know if is key D comma city or town, what does that give?
So for in this particular scenario, let's look at the first row. Okay. In when we are looking at the first row, what is your D? D is empty, right? So it will not get into this particular block, correct?
Yes.
It will go into this else statement. Now in else statement, what it is saying that add a new key, right? This is how you add a key value pair, right? In a dictionary. So what is your key here? X dot city or town. For first element of your dictionary, it will be erode, right?
Yes, sir.
For erode, it is storing the marks physics 64 into it, right?
Yes, sir.
So
it is a physics marks only, right? The value.
64 mark value is being stored into D of erode. Correct?
Okay, sir. Got it.
Yeah. So it will again go for the next row. Again, you will go again and will ask whether in the dictionary D, do you have erode present or not? If it is not present, then add. Otherwise, if it is present, test whether x dot physics marks that is from your row is greater than the value x dot physics. Suppose you had another student from erode, right? You are checking whether the current student has more mark than the previous one. If that is so, you are updating the physics mark, right?
Yes, sir.
So that way you are adding only the highest mark into this dictionary, right? The dictionary
the
will
physics
have
mark must be greater than the physics mark of the previous students. Yes, sir.
Previous student. So this will always have the
and we're
highest
updating
physics
the
mark
highest mark. Yes.
for that particular city. So you will have the basically your dictionary will store all the city names, right? There will be no repetition, and it will only store the highest physics mark for each of the city. Correct? Now you come in here. Now you are saying that for each key in keys D. So what your keys D list will give you?
The cities.
Cities. Okay. So you will have a list of cities. Now it is asking whether the key, right? It is asking whether the value is 0 in first iteration, right? A is equal to 0 is what it is initialized with. So suppose for case of erode, right? Is it 0? No. Then it is again testing if this key value is greater than A. That is true, right?
Yes, sir.
Then what it is saying
64 is greater than
0, right? In this particular scenario. What it is doing then A is equal to D of key.
D of key will be the physics mark.
That means the highest mark in that particular city, right?
City, yes, and B will be the list of cities from it. Yes, sir.
Understood. This will be the name of the city. Correct?
Yes, sir.
That is why you have this answer list of cities from which students have scored the highest physics mark, because this is again, eventually you're adding that your B
Yes, sir.
into your B. Okay.
Yes.
So what was the next question? The following question also 2.
Yes. No, not 2, sir. 7.
7. Okay. 3 was also someone asked from the practice assignment 7. Who had asked for this? We'll just go to 7. Question number 7. Okay, the following pseudocode is executed using scores dataset. What will city D of K represent at the end of the execution? Okay.
Hello,
So,
sir.
yeah.
Can you please enlarge a bit the code? Can you enlarge?
Okay. Is it? Oh, sorry. Yeah. Is it better now? Or you're still not able to see? Just a minute. Question number 7, right? Sorry?
That was better.
Previous one was better.
So I think 7 I got it. Can you explain question number 4, sir? Because I think it's from the scores data set.
Yes, sir.
Question number 4.
Yes, sir. So from the words data set.
Sorry. Yeah. Question number 4. The following pseudocode is executed using words dataset. What will D represent at the end of the execution? Okay. D is, it's a dictionary. So what does dictionary is storing is what you want to know. While table 1 has more rows, read the first row X in the table. I is equal to 1, A is equal to T. So for each of the row, this is being set, right? I is equal to 1 and A is equal to T.
Yes, sir.
So while I is less than or equal to X dot letter count. So X dot letter count stores what? How many letters there are in a word, right? In the words data set, if you look at it.
Yes.
Okay, this is from words data set, right? Yeah, so letter count is, how many letters there are in the word. So if you look at it, A, we are already initializing as T, while I is less than or equal to X dot letter count. So I has to be more than 1, right? It has to be at least 2 letter word.
So to enter
No, at least 1, like less than or equal to, na?
The letter count must be equal to 1.
Yeah, letter count should be less than or equal to 1, right?
No, sir, it should be greater than or equal to 1. Sorry, less than. Yes, sir, got it.
Right.
Yes, less than.
What it is doing? What is storing in A? Ith letter of the word. So A is initializes as, any random character, right? In this particular scenario.
Yes.
This is only to initialize the variable A, because we are reassigning A to the ith letter of the X dot word. So suppose your letter count is 4, right? While
Yes.
I is less than or equal to 4. Is it true?
True.
Given
Yes,
the letter count is 4. It is true, right? Only when it is true, while we'll keep on working on it, right? So you have A is equal to ith letter, right? So I is equal to 1 initialized. So it will be the first letter, right? What it
Yes,
is looking at, if not, is key in D and A. So this word, if it is not present in the dictionary, right? This is what it is telling, right? So is key DA will give you what? True or false?
No, sir, D means
No, is key
the
will
letter
give you.
must be present in the word.
Yeah, but what it is doing, this particular statement, is key.
false.
So because you have initialized your dictionary as empty, initially it will be false, right?
Yes, sir.
If this is false, then
To be
not
true,
false
so
is
D of
true,
A
right?
will be 1. Okay, sir.
Right. So that is why for that particular letter, you have count
So it will be for
the
T1.
value
Okay, sir.
given
Got
to
it.
1. Sorry.
So, yes, sir. So it will D will represent the D.
So if
letters with
the letter is already present, it will go to else block and it will increment the value,
It will be
right?
the frequency count of every letter, right? And not
Yes, in
letter
the word.
of each word.
Each word. That is what
So
D
no, sir,
is.
just one doubt. So will it be the frequency count of each letter of the words data set, or frequency count of the letter of each word. Like for example, if we take some word and the frequency count of each letter of that word, or the
Now you
entire
forget about
word.
all of this thing. Let me ask you one question. What is destoring?
The letters with the
Letters
frequency.
and its count, right?
Yes, sir.
In a word, so what you're reading the first row, X in the table, you're looking at each of the word, right? This is
Yes.
what X dot word is, right?
Yes, sir.
For each of the word, what your dictionary is storing? The letter and the count,
Yes, sir.
correct?
Yes, sir.
So what it should have? Suppose we are done with one word, right? Suppose we are done with the first word. Read the first row X in the table 1. So where is your data? Words data set.
Sir, what I is equal to I plus 1 stands for the next letter or the next word?
So once, suppose I am saying that I is less than. So initially we assume that the letter count will be 4, right?
Yes, sir.
So it will go to the at the end of it. Now you need to go to the next letter, right? In the word.
Yes, sir.
So I am incrementing by 1. So is I less than? Now I is equal to 2. Is 2 less than or equal to 4? True, right?
So it will be iterating till the values
Yes.
number is
So
equal to number of
now
letters.
ith letter will be second letter, right? Likewise, it will go till I becomes equal to your letter count.
Yes, sir.
So it will go and iterate for each of the letter in the word.
Sir,
That is
any
why
particular
what I is doing. Sorry.
any particular reason why A is equal to D in line number 4?
So this is just to initialize it. Like, you know, you have initialized the value. In this particular scenario, you have done an empty dictionary, right? Likewise, you have initialized A to be a character variable. That is what it is, right?
No, I thought the data set is having the first word as
It
D.
can be anything. It can be A, B, C, D, E, F. Because what you are doing, you are simply reassigning the value, right? The ith letter will become A, correct? So this is just to initialize in your code. It can be A, B, C, D, E, F, G, H, anything, but it has to be a letter in this context. Is it clear?
Yes.
Or do you still have doubt?
No, sir, I'm clear with this.
Okay, okay. Which question next in this?
So 7th one.
Okay. What is your doubt in 7th one?
So it is asking what will the city D or K represent?
Following pseudocode is
So
executed.
city D is, I think they're asking the value of that particular key source.
So what will city DK represent at the end of the execution? Okay. City D, let's look at the code. Okay. Now what? It's an empty directory. We are initializing it. Okay. Now what we are doing, we are iterating through all the rows. We are operating on scores dataset. Let me just pull that up. Just give me a minute. So the scores data set is, yeah, so it is going through each of the row, right? What do you have in scores data set? You have name, gender, date of birth, city, town, mathematics, physics, chemistry, and total mark, and you have card number. So what we are looking at it, while so again we are going from city and town detail, right? So read the first row X in table. If we are looking at whether this town exists in the information regarding this town is present in the city D or not, right? Then what we are doing, whether for that particular if it is present, right? Just tell me what does this will do. Is key city D X
Town or
dot town,
city is, it be false.
right? So for the
key is checking the in city D dictionary there is a key of town X dot town city or not.
exactly, so it is just checking for the key. If it is there, it will be true. Otherwise, it will be false, right?
Yes.
In the initial first row, it will be false, right?
Yes.
So it will not
Like
go
initially
into
because
this
the
loop.
dictionary is empty.
So what is its so block is not complete yet, right? For this if block
Go
only
in the
ends it
else
here.
block.
So it will go into else block, right? What it is doing in else block?
Yes. It is a creating a dictionary with
Okay.
a key as the first key as a town city, and inner key is the gender, and physics marks is the value.
Value. So for that particular city, we are extracting also the gender value. What multi-key dictionary this is, right?
Yes, sir.
Yes,
And
sir.
it is assigning x dot physics value.
Physics
Yes, sir.
value as the
Hmm.
dictionary value.
But do you think this else is for this if, or this else is for this inner if?
Inner if, sir.
Inner if.
Right. So if this is false, which else block it should go to?
The line 14.
Right. This else block it should go to, right?
Yes, sir.
What it is doing for the first step now? City
It's
D.
First,
creating the city
he is
X dot
creating an empty dictionary and doing the same
not
Right.
empty
with
But
dictionary setting.
what
The
empty
first
dictionary it
key
is
is
creating for? It is creating for x dot town,
for the
right?
X dot city or S, sir.
To make it multi-key dictionary, right? That is what it is trying to do. It is for each of the x dot town, it has its own dictionary.
Yes,
And
sir.
in that, you are storing the x dot gender, x dot physics marks as a key.
Yes.
Correct? So, and then you're moving on, right? So again, it will ask you, is key city D? So what was the question? It was asking what city D of K will represent at the end of the execution. Okay. So
Yes, sir. So what does city D of K stand for?
yeah. So tell me, city D of K will be x dot town, city D of town, or city D of town and gender. It will be.
Sir, I know, sir, it is the particular city K and further on gender, and highest mark, is it because?
No, that we haven't seen yet. Okay. So
Okay,
if
sir.
suppose for the first row, we already know the first city was what? Erode, right?
Yes, sir.
So it will just it will create a new dictionary
Key
for
for you.
erode, right?
Yes, sir.
And in that, it will add a new key x dot gender, and in that x dot physics marks is being stored. Correct?
Yes, sir.
So suppose now I go again, and suppose the second row also has erode in it. So it will
Yes,
again
sir.
ask, is key city D x dot town? It is true because second row also has erode in it.
Yes, sir.
Then it will ask, is key city dot x dot town and x dot gender? Suppose in the first part we had only female, right? But the second one we have male. So
Yes.
in that scenario, will this be true? No, right?
False.
It will be false. Then it will go to this else block. Then it
Yes,
will
sir.
ask you to add another gender, right? So you have, suppose in the first one you had female, now you had male,
Yes,
right?
sir.
Which is storing x dot physics mark. Then again, suppose the third one is also your erode city, and in this scenario, suppose the next one is also female. Then it will go into this next if loop, right? In this if loop, what it is testing, whether that particular city and gender x dot physics marks, the current physics marks, like whatever this row is it higher or not? If it is higher, then we are updating that mark, right, for that particular gender, right? So at the end of the day, city D will store what? Hello?
Yes, sir.
So you already know that we are storing two keys. One is for city, another one is for gender.
Yes,
right?
sir.
And what we are storing the highest mark
Highest mark, yes,
for
sir.
both of the genders, right?
Yes, sir.
Just by using another dictionary, dictionary into dictionary, right? Nested dictionary.
Yes, sir.
So now given this information, what does city D of K will represent? Tell me out of this four.
With the highest physics marks. And after that, I am here, sir. City K with gender, and then the highest physics mark with the gender.
Right, and that too for a particular city K, right? Hello?
Yes,
Your
sir, that
first
I'm
key
clear.
is city, right?
Yes, sir, that
Yeah.
I'm clear, sir.
Yeah. So, which is why. So, do you understood the answer, right? To this?
Yes, sir, I am understood.
Okay. Which question next?
So,
In
like,
this?
can you just clear someone else's doubt and then ask?
So
Okay.
week 9 practice assignment question 2.
Okay, week 9.
What is the answer of this question, the CTDK?
I'll just check. You tell me now what we did after our discussion. What do you think our answer should be? Very. This was it? No, not this one. Number 4 was it?
Number 7, sir.
7, sir.
7. Yeah. So looking at it, what do you think the answer is? A dictionary with
Second one,
gender
yeah.
as a key mapped to the highest physics mark scored by that gender in city K.
Yes, sir. This is right.
Right? This is what it is, right? The difference
Yes.
between the two is only highest and lowest. And we clearly
Yes,
know
sir.
from this conditional it is the highest, right?
Yes, yes,
That
Yes,
is what
sir.
the answer should be.
yes, sir.
Okay. So so you said week 9
Practice.
activity question 2.
The practice assignment question 2.
Practice assignment question number 2. Just give me a minute. Question number 2. Yeah, this is right. This 2 to 4 or just 2?
So if you could explain me the first part, I'll be able to do the rest.
Okay, consider the following table containing the scores of n students in a class. Assume that all scores are between 0 and 100. The scores in the, this is the question, right? The scores in the first and last row are shown as an example. Okay. So you have serial number for the student and then you have scores of that respective student stored in the second column. The actual scores may differ. So refer only the table header to answer all the questions. Okay. This information is stored in a dictionary S with a serial number as keys. So if I ask you how this S will be, S of 0 for the first row, right, is
Yes,
equal to
sir.
50 is how it is stored, right? A graph G generated from this table in the following manner. Okay. So let me ask you, how do you generate a graph?
So this
What
is
does graph
the,
stores?
so this is what I'm facing the problem in. I'm not able to generate the graphs from the given information of dictionaries.
Okay. Given a pair of student ij, there is an edge from I to j if and only if I score is strictly greater than of j. This is your condition for the edge formation, right?
Yes,
So
sir.
you have, suppose what your, in this particular scenario, if I were to generate a graph, what will be your nodes or vertices?
The nodes would be the
Sequence
serial
number.
numbers. Serial
Yeah,
numbers.
serial numbers or sequence numbers, right?
Yes, sir.
And now you know what the edge will represent, right? Edge is only there from I to j if I score is strictly greater than j, right?
Yes, sir.
So in this scenario, for suppose for 0th and n minus 1, it only exists if if I score is greater than n minus 1s. That is not the case, right?
First, we have to create the matrix.
So what do you call it? Call that matrix?
A.
Sorry?
Matrix A.
No. When you generate such a connection matrix, what do you call it?
Adjacency matrix.
Correctly. That is what it is, right? Adjacency matrix. So what will be the values? Will it be the marks or will it be just 1 or 0 in the adjacency matrix in this case?
One or zero.
Right? Because this is not a labeled
If
graph, right?
there
This
is a
is,
edge, then 1 or 0.
yeah, if there is an edge, it is 1, otherwise it is 0, right? This graph represented by a matrix A, assume that the dictionary S has already been computed. Okay. Now study the following pseudocode. Okay. N is equal to length of keys of S. Okay. What will it store?
Serial number.
Sorry?
Serial number, sir.
No, keys of S is a list of serial numbers, right?
Yes,
Yes,
sir.
a list of serial.
And length of that will be total number of keys which are present in the dictionary, right? S,
Yes.
right? So that is what the n will store. Okay. In this scenario, what it
Number of
will be?
students.
Yeah, but in this scenario, it will be n minus 1, right? N will be n minus 1, given this example.
Yes, sir.
Correct? Suppose I had 100, then it will be 99,
99.
right? N. Okay. A is equal to create matrix n by n. So what does create matrix will do?
Creating a matrix with the length of keys of S.
No. So you will have n columns and n rows, and you will have all
Yes.
zeros, right? With this function,
Yes, sir. First
right?
we
It is a
zero.
null matrix, right? You will have of n by n length, n by n dimensions. For each R in rows of A, for each C in columns of A. So R is, we are going for each of the row first, and each of the row we are moving for each of the column. Correct?
Yes.
So what we are comparing in here? If S of R is greater than S of C. What is R? R is your row, right?
Rows.
Suppose in this
Yes, sir.
scenario, if it is 0, it will compare for all of the n minus 1 cases, right?
Yes, sir.
Right? So suppose we start with 0, it will compare it with 0 first, then 1, then 2, then 3 till n minus 1, correct?
Yes,
And for
sir.
each of the case, we will see whether the value stored in S of R is greater than S of C. If that is true, then we are entering value in the row, right? A of R of C, it will become 1 only when it is greater than. So
Okay, sir.
if I pull, just give me a minute. Understood?
Can you
So
write
what
and
your
show?
adjacency matrix you just, hello?
Yeah, I'm also requesting the same. I mean, can you write it and show, because it's
That's
unable
what
to
I'm,
visualize.
yeah. So just let me copy paste the code. Okay, this is the code, right? Now what we are doing, your n is what? Small n, sorry. N is
Number of students.
total number of students, right?
Yes, sir.
Okay. In this scenario, your counting starts from 0, right?
Yes.
So it will be n minus 1 as per the given table. If suppose for our case, we assume n to be 10. So n minus 1 will be 9, right?
9.
For n is equal to 10. Okay. So, okay. Next is what? A is your matrix, right? So A is a matrix of, let's take a smaller number. Take 3 in this particular scenario. Okay. So that we can manage. So A will be a matrix of what?
2, 2.
Sorry.
4,
3,
4.
4,
If n, the small, this total number of students you have 3, it will be 2, right? The value?
Yes, sir.
Okay.
Total number of students, or will it be 3?
If this is 3, then n is equal to 2.
No, if total, this is not n.
So which question are you solving?
Practice assignment 9, question number 2.
Okay, total is equal to 4.
Total number of students are 3. Then in this scenario, let's
2.
forget about this. N will be what? 3, right?
No, if the total number is 3,
This
then it's
n.
n minus 1.
This n I'm talking about. Let's just forget about what
Okay.
we have seen, right? Because your counting starts from 0, right? In the
Yeah.
table. It goes up to n minus 1, right?
Mm.
But the total, if you count it, it will always be n, right? Even if you start
Correct.
from 0 and go to n minus 1, right?
Mm,
In that sense, it will be a matrix of 3 by 3, right?
Yes, sir.
Yeah.
Right? So you have 0, 0, 0. Then, sorry. And again 0, 0, 0. Then again 0, 0, and 0. Correct? This will be
So
your
how
A.
how do we know that A would be a null matrix?
This create matrix is a function, right? I think this is what has been taught also in lectures. So create matrix is a procedure
Yes, sir.
which creates a null matrix, right?
Okay, sir.
Of given dimensions, right?
Yes, sir.
Okay. So this is a procedure. This is procedure is operated on, and this is what we are providing n and n. It is giving you an output of 3 by 3 matrix. Okay. Now you know what adjacency matrix is, right? Actually, correct me if I'm wrong. Spelling is right. What it stores? What adjacency matrix stores? Hello, am I audible?
Yes, sir.
Yes,
You're
sir.
Yeah. So just tell me what adjacency matrix stores. What information?
So if
If
the
the
score
two
is
rows and
greater
columns
than,
have an edge, so it stores one.
Right. It stores information regarding edges, right, present between the nodes or vertices. It
Yes.
stores information about edges between corresponding nodes or vertices, right? So what essentially this code is doing here is it is creating an adjacency matrix for your data, which is already being provided. This is what S is your dictionary, right? Dictionary which stores what?
scores of the
S number
students.
as keys and
Score as
values
value.
and bring scores as values, right?
Yes, sir.
Okay. So for example, S of 0 in this particular use case is 50, right?
Yes, sir.
And S of n minus 1 in this particular scenario is 89. Okay. So what we want to do is so in this particular scenario, what your 0 to 3 will be your, so the code in here. So once you generate a null matrix of n by n dimension, that means you have n vertices, right? N number of vertices, and you want to know the connection information between those n matrices. So that's why you have n by n matrice. And in there, you are looking at for each of the row and for each of the column. For each of the row, you are going for all the columns and you're comparing whether the corresponding values are higher than 1. Like if this condition is true, then you're assigning it value of 1. Otherwise it will remain 0, right? Because you have initialized it as a null matrix. Correct?
Yes, sir.
So suppose you have a case where your S has suppose 0. We already, let's just take 50. S of 1, so you have 76. S of 2 you have suppose 43. Okay, so we have information regarding 3. Given this information, can we make an adjacency matrix out of it? So what it is doing for each of the R in the rows of A. So what is A? A is your matrix, right?
The null matrix.
Right. So for each of the row, for R, when it is 1, it will work on this first row, right?
Yes, sir.
So what we are doing, so A is being updated in such a way that, tell me, So when R is zeros for 0th row, it will go for the 0th element, right? Because your C will also be 0, right? For the first column. Is this
Diagonal will be 0.
yeah, R is 0 and C is also 0, right? For the first case. So this condition is not true, right? The value, suppose this is your value 50, right? 50 is not greater than 50. So this will remain as is. So the first element of this will always be 0. What
Yes,
will the
sir.
second? Now, again, the row is still 0. Your column is now 1, right? Now
Yes,
for
sir.
the first column, now S of 0 and S of 1. That is what the comparison will be, right? So what is your S of 0? 50. And your S of 1 is 76. So is 70 is 50 greater than 76?
No, sir.
No.
No,
No.
right?
False.
So the second one will also be 0. There will
0.
not be any of the edge. Okay. Now we will move to the third row, right? So for again, R is equal to 0 and
0
C is
and
equal to
2.
2,
2.
right? So is 50
50 and
greater
43.
than 43?
Yes, sir.
Yes, right?
True.
So this will become 1, right? Now we are done with the first row. What will be the second row? Now your what?
R of 0.
R
C,
is your
R of 1, C of 0.
R1 C0.
so R of 1 is what? S1 is 76
76.
and 0 is 50, right? Is 76 greater than 50?
Yes, sir.
Yes, true.
So what will the value?
1.
1, right?
1.
Okay, so let's look at the second value. So is R is what? S of 2 is greater than S of 2?
1.
No, right? No, is S of 1 greater than S of 1? No, right?
No, sir.
So it will be
No, sir.
0,
0.
right? Now S of 1 is S of 1 greater than S of 2 for the next
Yes, sir.
Yes,
iteration?
sir.
It is
True.
true, right? Then you will have 1, right? Correct. Okay. Now for the last one, tell me whether so we are looking at S of 2 and we are comparing with 0, 1 and 2, right? So
Yes, sir.
is S of 2 greater than S of 0?
No, sir.
No, right? So we have 0. Okay. Now tell me, is S of 2 greater than S of 1?
No, sir.
So again 0. Is S of 2 greater than S of 2?
No, sir.
You have 0. So from this, you tell me how the graph should look like. So you have, suppose 0, sorry, 0, 0, 1, 2. Tell me, is there an edge between 0 and 1? Looking at this matrix. This is your
No,
adjacency
sir.
matrix.
No.
0 and 0, there is no edge. 0 and 1?
No.
No,
0,
right?
2 is there.
2 will be there. 0.
Yeah, 0, 2 is there is an, right? So you will, sorry. So you'll have, sorry, you'll have an edge here, right? Now you tell me whether one, this
1, 0. 1, 0.
one has with 0?
Yes, sir.
Okay. One
And
with 1 is not
1,
there
2.
and one with 2 is
1,
there,
2.
right? So where should I put it? Hello? So what you said?
1 with 1 and 1 with 2.
1, 0.
1 with 2 is there,
1,
right?
2.
Yes, sir.
1 with 2 is there. 1 with 0 is there. Okay. And then 2 has any edges?
No, sir.
No, sir.
None of it is there. So how this is how is this how your graph will be?
Yes, sir.
But then 2 has edge, right? This will be directed graph or this will not be a directed graph? Hello?
Sir. So
This
if
is
you
a
don't
directed
mind,
graph or this is not a directed graph?
It's directed.
Right. Otherwise, you will see that everyone has edge with everything else, right? Which is not true. So 0 has what? Edge with 2. So there should be an arrow here, right? Pointing down. So I don't have a character which will do that. But you understand. So there should be an edge between these two. So from 0 to 2 you have. From then 1 to 2 you have. 1 to 0 you have.
Yes,
right?
sir.
And 2 doesn't have any edge with like directed node anywhere, right?
Yes, sir.
So just imagine there is an arrow here and then arrow going to 2 and arrow going to 0.
sir,
Okay.
can you just explain one time? I mean, how 0 is having 2 edges here? Because S of 0
0
is
doesn't have 2
50.
edges. So let me just draw. Okay, just give me a second. I'll just open another app. Okay. Just hold on a minute, okay? I'll just share entire screen. Okay. Is this visible? Pent?
Yeah.
Yes.
Okay. So let me just quickly draw. Suppose this is your 0. This is your 2. This is your 1.
So this is still actually question practice assignment 9 question 2.
Sorry?
Are you solving practice assignment 9 question 2?
Yeah.
Yeah. We are
Yes.
still in 2 to 4. Okay. We're
So
just
I have
explaining.
some more doubts, sir. When can I ask?
Yeah. Just give me a minute. Okay. I'll just clear this. Okay. But you are clear, right? How this is.
Sir, yes, sir. I am clear with this question.
Okay. So you have 3 here, right? So you have edge from our.
Approximately how long will this take, sir? Because
Just a minute. Okay. Just give me a minute. So, sorry. This is 0. Right. This is 0. This is 1. And this is 2. Right? So you have an edge between what? 0 and 2, right? So the edge
Yes,
will be
sir.
directed edge. So one has edge with 0 as well as one has edge with 2, right? So it is directed like this. And it is directed like this. But 2 doesn't have any edge towards 0 or 1. Understood?
Yes, sir.
Yeah, who knows? Somebody asked me this query.
So, if I can repeat one more time, I mean, if 0 means the first is S of 0, 50, and it has 2 1s in the matrices, 3 of 3, A is equal to 3 of 3. There are 2 row number
so this
row
is for
number 1 and column number 3.
This is 0.
1.
Just give me. It's 2. And it's again 0, 1, and 2. Okay. So these are your nodes, right?
Okay.
And from 0 to 2, there is a edge, right? This is a directed map. So there is no edge between 0 and 2, 2 and 0, because 2 doesn't have any of the edges going to any of the other nodes. But 1, you can see it is directed toward 0 as well as it is directed towards 2. So you have 0 as well as 2. Is it clear or are you still confused?
Okay. So, okay.
Yeah. So what was your query? You said you had more queries in this question. Hello? Whose question was? Yeah.
Yes.
Yeah. All right. So your question was a row R in the matrix has 3 entries that are equal to 1 and rest are 0. Which of the following statement is statement about the student R is
3
true.
entries means there will be 3 students who have scored less than R.
Row R of the matrix has 3 entries that are equal to 1. Yeah, and rest are 0. So 3 of the students have scored more than R, right?
So it will be less than R, right?
What you're testing for? So yeah, so R's score should be greater than C's.
So, but why can't it be equal to? Because in the line 5, we are just checking if R is greater than C. So here we can have R must be less than or equal to C, right?
Where here?
Yes, sir. Here it is greater than C. So shouldn't it be there are 3 students, exactly 3 students have scored less than or equal to student R?
Yeah, equal to is possible now.
So, but no, but then the option is given option 3 as the correct answer.
There are exactly 3 students who have scored more than students. So you just tell me, looking at this. So a row in the matrix, just take a look at this, okay? Suppose your R is in this case, on this one.
Sir, how there is become 3 student?
Sorry?
Where it is given in the code that there are 3 students?
Sir, here the
It is
correct
not given.
answer is given as option 2, sir. With that, I'm very clear.
Hmm.
So the student must have scored. Okay, sir, got it. I got it, sir.
So in any row R, there should be 3 entries that are equal to 1 and the rest are 0. Okay.
Yes, sir.
Sorry, sir, I couldn't understand. If you could please repeat.
So you tell me, just
Yes, sir.
take a look at this question, okay? Our row of the matrix has 3 entries that are equal to 1 and rest are 0. In our example, we have taken 3 students, right? So more equating example would be this case, right? Suppose.
Yes, sir.
Right, where there are 2 students, which has for which this condition was true. What was this condition? For S of R is greater than S of C. What was your S of R? R was your row, right?
Yes, sir.
So the number 1 student, right, has more marks than whichever are there in the column. Right?
Yes, sir.
What was your S of 1?
Iterating through the rows and
76.
columns.
So in this scenario, you are going through, for a particular row, you're going through the column, right? In a column, you wanted to see how many of them have scored less than, or in how many of the cases the student has scored more than, the students which are present in the your list of columns, right? So there were only 2 students.
2
right?
students, yes, sir.
So what was our condition? Number of students who have for whom R has scored more marks than them. So there are exactly 3 students who have scored more marks than student R. There are so you just tell me which one do you think is the right answer?
Option B, I think.
So it has to be option C, sir.
Just take a look at this code.
So it is actually very simple, sir, because the answer is directly there in the line. The code is directly there in the line.
It is there, no? In there.
Yes, sir. Option 5.
Yeah, no, somebody else has this doubt, right? Just tell me which of this answer and why is it so? We just discussed this code, right? Just now. For when this condition will be true, S of R is greater than S of C. When that particular R student has more mark than those C students, right?
Yes, sir.
So for whom the value will be 1?
For the one who has scored more.
So what zeros represent in this
False.
case? No.
Less
This
marks.
condition is false for, what does that mean?
Less marks, yes, sir.
Less marks. Less marks
Right.
from R.
Yeah. So you tell me which of the following is true about the student R is true. There are exactly 3 students who have scored more than student R. Is it true?
No, sir, false.
No, sir, false.
False, right? Because R has scored
B
more
option,
marks,
I-
right? There are at least 3 students who have scored less than student R. Is it true?
Yes, yes, I
Yes, sir,
think
it can be.
No, but it says at least. That means there are more than like, this is what does at least mean?
It can be more than
less
3
than
also.
equal to.
Right? At least this is the least. There can be more students. Is it true?
False.
False,
No,
right?
sir. Okay, sir.
So how it is false?
You are
Because
saying
There
there
are
are
only 3 students.
there are only exactly 3 students, right? Because only for these 3 students, this case was
okay, so
true, right?
then option 3 is right. Yes,
There is no at least in here, right? So
yes, yes,
if this is true, then even 4 is also okay, 5 is also okay. That is not the case, right? So
yes.
Yes,
So
sir.
the
then
next one
option
is
3.
there are exactly
Option.
3 students who have scored less than student R. This is true,
Yes,
right?
this is right.
Yes, sir.
Yes, sir.
So this is essentially your less than or equal to or something of that sort, or greater than or equal to. So you just need to take a look at what it is saying. Okay, question number 3 also.
Sir, I'll be able to solve them now. Thank you so much, sir.
Okay, what was the next question?
The mock for in term question number.
I
So
think
practice assignment
assign.
8 also have the notes.
Just a minute. There were more
So
question
go through
in
these
9, right?
data.
Sorry,
DFS procedure.
DFS. No, 9 is over, right? We will go to 11. I think week 11 somebody asked some questions.
Sir, I asked for week 10, question number 9 and 10, graded assignment.
So I
Okay.
asked for a practice assignment week 8.
Okay, week 8 practice assignment.
Wish the
What was the question number?
So question 1.
Just one,
Okay.
first question.
So once the second one I haven't tried yet, so I'm not sure.
Okay.
Mm.
Question
The
number
others
1.
I'm
What
trying.
is the doubt?
Yes, sir, it asks what will Z represent? And,
Okay, so just take a look at our
can you just
approach,
explain
right?
the codes?
Yeah. So we are like break down your code. Okay, I see a block here where we are defining something. I see a block where we are iterating over something. I see we are defining something in here again, and again we are iterating over something, right? So you have
Yes.
2 iterators, one in while loop and one for each. You have 2 zones where you are declaring something. In this scenario, you are declaring something here, you're declaring something here. Okay, so what you have declared, okay, you have declared an empty dictionary and you have initialized 3 variables with 0. So if it is 0, that means it is definitely counting something or adding something, right? It is doing some integer operation. Okay, now we are
Yes.
going which data set it is? Scores data set, right?
Yes.
So while table 1 has more rows, we are going through row by row, and what we are doing, read the first row X in the table. What we are doing with the A is storing what now?
0.
A
A
initialize
storing
0,
0, so it will be the total marks.
for each of the iteration, it will keep on adding the X dot total, right, to the A.
Yes, sir. Then C will be incremented to 1.
C is incrementing, so it is actually counting number of lines, right, in this scenario.
So
Number
sir,
of rows.
should I just, yes, sir.
Sorry, what was that?
So for the 7th line, we are just checking if the town or city is part of the dictionary, and then we are incrementing the total mark of that particular city, sir.
No, so is key is what, again, true or false statement. What you are doing, you just want to find whether that town or city was a part of dictionary D or not. Is there
Yes, sir.
entry? If it is not, then we are going to else. Let's take a look at the first set. Okay, first line, this is not true. Else, what it is doing, you have an key entry for key, right? Key X
Yes,
dot
sir.
town for the dictionary D, and you have what, sub keys in it, right? It is storing a
Yes,
dictionary
sir.
in it. So you have total, which is given a value X dot total, and count is given a value of 1.
Yes, sir.
Right? And then we are moving. Then we are going again to the next row. If suppose like the previous example, we said that let's assume erode is occurring 3 times consecutively. So first time I added whichever the student was, right? From the erode, his total was added and count was added to 1. Next time,
Yes.
when we will go through, again, A will be incremented for the next student also, and C will be incremented by 1.
Yes,
Then
sir.
if is key, now it is asking whether erode is present or not in dictionary. It is present. Now what it is doing, it is calling this key, right? Total key.
Yes, sir.
For that erode.
So if it is
key.
present, the total is added and the count is also added.
So it is just incrementing this, right? In this particular
Yes, sir.
scenario.
First it is initialized to 1 and then it is incrementing the total marks.
So it is adding. This is
the total marks
adding
of that particular
your,
city.
yeah. So you are cumulatively adding in here the total marks and you are incrementing the counter by 1.
Yes, sir.
Right. And then again, you keep on doing this till you have what? You have unique keys for all the cities, right? And city wise, you have information of grand total mark and a grand count, of total number of students present in that from the which belongs to that particular city. Correct?
Yes, sir.
Right. And what you're averaging at the end of all of this loop, your A will
the
be
total marks by the count.
Yeah.
Yes,
A doesn't require, which total mark you are counting for, right? It is counting for all of the students which are present in each of the rows, right?
And it is for one particular city or for all cities?
This is for all the cities, right? This is for all the cities and all the students is
And
counting.
C is also all the entire students.
Right. So what A average will be? It will be averaged over entirety of the students, right? So grand total, cumulatively accumulated grand total of all the students' marks divided by total number of students, right?
Yes, sir.
That is what it is averaging. So
Yes,
on an average, a student gets how many marks is what average is capturing, right?
Yes, sir.
Now Z is equal to 0 is what is being initialized. Now you look at for each B in keys of D. Keys of D will give you list, right? List of cities it will give you.
Yes,
list
sir.
of cities, what will be B? It will be individual city, right?
Yes,
for
sir.
each of the individual city, I'm looking, I'm adding another key, right? Average.
Yes, sir. So it will be
right?
the average.
So in addition to total and count, I have one more key which is being
So I
added.
think the total
average.
and count is for one particular city, sir.
Sorry?
I think the total and count is for one particular city.
Which total?
Like the total.
Yeah. The size dot total is for the particular city.
Yes, sir.
Yeah. So when you call upon D of B, suppose in this case erode, D of erode, we are adding a new key called average, and what we are doing, we are dividing the total divided by count for each of the from its own keys, right? We are generating extra data average, right? Now what we are asking, if D of B, suppose in this case erode, this average key has more mark than average. We said average is a grand average, right?
Yes, sir.
Only when this is true, you are incrementing D, correct?
Yes, sir.
So what does D of B of count stores?
It will be
Total
the
number of students, right?
Students, sir. Yes, sir. Total of
right,
students.
from that particular
yes, sir,
city.
I got it, sir. I got it.
Right, that's what Z is being storing.
Yes, sir, got it.
So what your Z represents at the end of the execution?
Number of students from that cities. Average total mark of the city is more than the average mark of the cities. About it.
No, tell me what
Option
Z
number
represents. Number of
Option
students,
A.
like don't look at the options. Tell me, Z is what?
So it will be
Total
number of students from one particular city, sir. So from a city.
That is all there is to it, right?
Yes, sir.
Or does it also count this
number of
there?
students
city of
average
B, and
greater
count
than
will be
the
the number of so count stands for number of students.
Total
and,
number
B
of
is the city.
From a city for which
and the 21st condition.
Average marks are greater than overall average.
Overall
right?
average.
Yes.
That is what it is, right? Z.
Yes. So can I try?
Number of cities from the cities with average total marks of the city more than the average total marks of the data set. Option A is correct, right?
Yes.
Yes, sir.
Yes.
Okay. Which next question?
Sir, graded assignment week 10, question number 9 and 10.
week 10, question number, grade assignment, question number
9 and 10.
9 and 10. Just give me a second. Okay.
So will you be extending the session, sir? We could ask more doubts.
Yeah, it's fine. Question number 9. Yeah, so consider the adjacency matrix constructed above. Assume that there exists a procedure remove duplicate, which is a list of inputs and removes all the duplicate element in the list. When will find good set matrix return true? So what was constructed above? Okay, this question number 9, right?
Yes, sir.
Okay, the following pseudocode is executed using shopping bills data set. Each customer is being assigned a unique index between 0 and n-1. Dictionary D has already been computed with keys as index and values as list of distinct shops visited by the corresponding customers. That the existing procedure. Okay. Just give me a couple of minutes, okay? I'll be back. Just give me a minute. Yeah. Okay. So what does D represent? Hello, am I audible?
Yes, sir.
A dictionary with
So what does it has? What are the D? Sorry. What is the key?
so keys are the index numbers.
So index number and value.
List of distinct shops.
Is list of
Distinct shops.
right by a particular customer. Okay, assume that there exists a procedure intersection. So you have a procedure called intersection, which takes two lists as an input. So probably L1 and L2, and it gives list which contains the common element in the input list. And L3. Okay. Okay, the unique indexes are the customer, right? For each of the customer is kind of a customer ID, right?
Yes, sir.
Okay, so what it is asking?
Sir, customer ID or bill number?
Each customer is being assigned a unique index number 0 to n-1,
Okay.
right? That is what it is, right?
Yes.
So that is not bill ID, this is customer ID. So each customer has only one ID. Suppose Ram has visited 3 shops, he will have only one unique ID, not, based on each of the shop, right? And then the keys are actually storing what? List of distinct shops. So suppose in this particular scenario, D of Ram has visited, say, shop 1, shop 2, and shop 3, correct? Suppose he has visited these 3 shops. This is what your dictionary is storing a list, right?
Yes, sir.
Okay. So what was the question but in here? The following should go to each customer assume that there exists a position in this the list. Hey, there is no question in this. Or this is an okay, extra
Sir, this is
information
a-
for the
yes.
okay. So it says that it is creating an adjacency matrix in here. Okay, so you just tell me how it is being making an adjacency matrix in this scenario. So you have n length of keys of D. So what length of keys of D will give you?
Sir, the number of unique IDs present in that, basically n.
Customers, no, sir, number of customers.
Right, total
Yes.
number of unique customers, right? Or just customers
Sir,
also?
the IDs are unique, so customers are unique too.
So this is kind of unique, right? Okay. So we know that it is only going. So the matrix is created for. So what will be your edges in this case? What your edges will represent? Hello? Your matrix is again, what does it will create? Am I audible?
Yes, sir.
Yeah, so tell me what this matrix will create. So your nodes will be customers, right?
Yes, sir.
So your nodes or vertices will be your customers. And now we want to find how it is defining edges. So what is the condition for the edges?
So I
For
must be 1. If I is not
I
equal to
should not be
j,
equal to j. So so what do you mean by when I is not equal to j?
the 2 customers are not same.
But it is already an unique ID, right? Unique customers. So I and j should not be the same, right? In any
Yes,
case.
sir.
Sir, but when we are creating matrix, the same rows and columns are there, na? So that is why it is given.
So if I is not equal to j, what you are saying, intersection of di and dj. So what we said, right? Intersection is doing what? This is the procedure which is being called, right? In here.
Yes.
It gives you what? List, right? Which contains common element from both DI and DJ.
So I
So,
think this indicates the common shops of ING.
so between the two customers, it will give you what? Edges will be, what information it will contain? List of shops common between
ING.
two customers, right? Two
Yes.
nodes in this scenario. Nodes of, right? If suppose two customer has visited the same shops, there will be an edge between them. That is what it means, right?
Yes.
Matrix IJ is storing what? It is storing a list, right?
Yes.
So this, your dictionary in this particular scenario will be more of a list, right? Rather than just ones and zeros. And if there is nothing present, what it will be? It will be an empty matrix, right? Empty list, right? So you have an adjacency matrix which for each of the element there is either an empty list or there will be a list of common shops, right, between the two customers. Considering the adjacency matrix constructed above, assume that there exists a procedure remove duplicate which receives a list of as input and removes all duplicate elements in the list. When will find good set matrix return true? Okay, so we are creating another matrix out of it.
Yes, sir.
It's a procedure called
You know, they've
find good
taken
set.
3 customers in the
For each I in row M, for each J in column M, for each H in column M. So because you are iterating over
checking if
the list, right? For each I in
Yes,
row
sir.
will result in what?
Your customer.
Customer. For each J in column will result again in
Also
customer.
a customer.
Right? For each H in rows of M,
So
what will it?
I think they're taking a third customer and they're trying to find
Just say there are list. Sorry. List here. A list here.
there was taking the customers who have visited the shops which are already visited by customers ING.
Just give me a minute.
And they're checking if 2 pair and the other person has visited exactly 1 shop.
Yeah. So you're telling me that for each I in row, suppose your I is 0.
If we, like among the 3, each of the, when we take any 2, they must have visited only 1 shop.
Only one shop, huh?
So for line 6 and 7, they're checking if MIJ, they have visited only 1 shop in common. And D of H in the dictionary, where the shop visited by H must be the same as the, like I think MIJ, it stores a dictionary, right? There's a dictionary.
MIG is list, right?
Yes,
You
sir.
always operate first on a list, not on a dictionary, right?
Okay, sir. So MIJ.
What your MIJ? See, this is each of the element. Yeah, each of the element in your matrix is a list.
Stores visited by ING.
Yeah, so it can be empty or it will contain the list of stores visited by particular, list of stores visited by both the customers.
Yes, sir.
Right, that's what
and
it
I
will
think
be.
D of H means the shop visited by H must be the same as the shop visited by ING. Like the first shop means I think taking only one of the shops. The very first shop.
For H, for each H means,
things.
for each of the elements in the list, right?
So H means I think they're taking the entire column. So it will be HI, HJ, HK.
See, for the first iteration, right? Suppose this is your I. Your I's are your rows, right? This is your I and this is your J, right?
Yes. Sir, actually, I have not asked this doubt, sir.
Okay. Whose doubt was it? Just explain it to her. Let me correct you when I can.
So
Hello?
mine.
Yeah, what was your doubt?
Sir, actually, I was not able to get the procedure running.
Which this procedure, no?
Yes.
Yeah. So just tell me what for each I in the rows M does.
So it will go through the customers. For each customer, it will go.
You know that when we iterate over a matrix, for I is always a row, J is always a
Oh,
column,
yes.
right?
Sir. Yes. Sir.
So you're iterating for each of the row for all of the columns, right? And
Yes. Sir.
in that, what we are saying for each of H in row M, what does it mean?
So it is again checking through the rows.
No,
It
there
will
are
be the list of all the shops visited by head, sir, like irrespective of the other person.
for each H, is it a list of that particular element?
It
Suppose
will be
in
a
this,
customer, right?
yeah, suppose this is the zeroth customer, or this is the for zeroth row first
So, for
customer.
example, one, we have to check every shop visited by once.
Hmm.
Like the entire row, do we have to check in then to compare? Yes, sir.
Yeah. So list, you're creating an empty list. Just forget about all of this thing. You're iterating through rows. You're iterating through columns, and you're doing something for each H in row M, right? So you're still in rows. For each of the element in H, you're looking at if length of Mij is equal to 1. Suppose what length of Mij is equal to 1 means what?
Sir,
If
like
there
there
is
is
only
only
one
one
entry,
shop,
right?
One element in that.
Yeah.
I
So
entry,
if
sir.
the list is only one length long, right?
Yes, sir. There's only
And
one
what?
shop it is visited by INJ.
No. When you say length of M of INJ, what does it represent? M of INJ is a list, right?
Yes, sir.
This is suppose for I is equal to 0 and J is equal to 1. This is a list.
Yes,
It
sir.
is looking at the length of the list. If length of the list is equal to 1
Yes,
and
sir.
member of D of H is first of Mij, right? So it is checking for whether this D of H is a member of the Mij.
Yes, sir.
Does first Mij make sense in this scenario?
Yes,
No,
sir, because
sir.
it's only one element. So, anyways.
That is what we are testing, right? If it is only one element, then member of whether this particular H is a member of that Mij list. Only then what you're doing, list 1 is equal to list 1 plus plus Mij. You're
Yes,
adding
sir.
only in that scenario. And you're iterating through for all of the J's, right?
Yes, sir.
For each of the H and for all of the J's. You're doing that.
Yes, sir.
So yeah, whose question was it?
Mine.
Yeah, so what was your doubt in here?
So I did not get the procedure running.
Okay, so you understood these two parts. You are only confused
Yes.
in this part, right?
Yes.
Line number 4.
Yes.
From this onwards, what it is doing exactly, right?
Yes.
So forget about all of this thing. When Mij will be 1, in all three cases, it is looking at 1, 1, 1.
So, but the other two are like MIH and JH. No?
Which one?
So the other two are like are not MIJ. They are length MIH in the
So do
second.
you think this is like a 3 by 3 matrix? I mean, there are 3 elements. What do you call? it should return true. So the procedure find good set receives a matrix. So in this procedure, so let's take a look at the code in general. Okay, what the question was, assume that there exists a procedure, okay, remove duplicate. So the remove duplicate is being used here. What duplicate removes? Which receives the list as an input and removes all the duplicate elements in the list. When will the find good matrix returns true? When does it returns true? If the length of the list 1 is equal to 1. When the list of 1 will be true, is equal to 1.
So if there is only one element after the
Remove duplicate, right? That means
Yes,
each
sir.
of this process should only
They should have visited the
same shop. It is
same
only
shops, all the
adding,
three.
keep on adding only one single shop over and over again, right? In all of this thing, whenever
Yes.
this condition is true, it should, keep on adding the same shop over and over again. Only then it will be true. Otherwise, it will be false.
Yes, sir.
Yes, sir.
So it should have visited only one shop, both the customers. So what was the answer for
Yes,
this
sir.
question?
The second option.
If there exist 3 customers such that every pair of customers among them have visited only one and the same shop in common. If there exists. So if it is for 3 customers, right? There exist 3 customers.
So because list one is for 3 customers, so because we're checking
Yeah. So if it is for 3 customers,
the other two.
the adjacency matrix which is considered, constructed above, it is for 2, right?
Yes, sir.
Right. It is only for 2 I and J, right? There has to
Yes.
be another element K.
That is there in the question, sir. The 9th question.
Consider above. Assume that there exists a procedure. No, where it is? Consider the adjacency matrix constructed above.
No, sir. The H1 is the like for each H. We're checking for each row only, right? Because I and J line 2 and 3 is a regular matrix. For each H and row sum is like maybe the 3rd row or 4th row, and we're checking the shops visited by H.
So suppose
We're
I is
comparing
so let's just look at the condition when.
Yes, sir.
So you have an M matrix which is n by n dimensions, right? So what you are doing when for each I in rows of M, right? So suppose for initial case your value is 0, then for each J in columns of M, right? So it will vary from what, 0 to n, and then what you are doing for each H in rows of M. M. So M will also vary again from 0 to n, right?
Yes.
So for each element, for each 0, you're what? You have J variable for 0 to n columns, and then for all of the rows also. So you're iterating first through the column and then through the rows as well. So you're looking at 0, 0, 0, 1, 0, 2, and you're also looking at 0, 0, 0, 1, and 0, 2 in this direction. Is that what it is doing? Each of the row represents what?
Customers.
Right?
Yes.
Customer. So if we are comparing 3, there will be 3 customers, right?
Yes, sir. So first customers are kept constant for the first one, first row, first customer. Then for the first column, the first customer. they are kept constant, right, sir? And again, by considering the first customer, that is repeated for all the customers.
Yeah, for the first customer, you're going through all of the columns, all of the customers in row, and then again you are
So we're
going
going through
through all
all
of
the
the
shops, like the entire row.
yeah, entire row and entire column you are also visiting, right?
Yes, so like
And then you are constructing a list.
so I think row and column for one particular customer, it will be the same. Like the entire row.
Row and column for
So like if we take a customer H, be it the row or the column, I think the entire shops will be the same. That's what matters.
no. See, with first one, right? You are comparing 0 to 1, 0 to 2. With the third one H, you are comparing not only from 0 to 0, 0 to 1, 0 to 2. You are also including other elements into it also, right? There will be unique
Yes, sir.
pairs where you will have say 0, 1, 3 or 0, 1, 2 as a group into one, right? That is what it is doing. For that particular set, this list is being updated for each of the time. So
Yes, sir.
you
Got it.
for each of the pair where ij it should be 1. Okay, so length of ij when it is 1 in this scenario, when ij you have a unique one shop which is visited by both I and j, and then whether uh, the d of h, right? So d of h will give you what? The shop name, right? List of
Yes.
shops.
Yes, sir.
So it is looking whether it is also the part of the first ij of mij. But then your first of mij will also be, because the length of mij is 1, right? Your first of mij is essentially the same element, right?
Yes, sir.
Whether they are the same or not, what it is comparing. And then if this both are true, whether h was a member of this list and the length of that list is equal to 1, then list 1 is equal to list 1 plus plus mij. So it is appending that list mij. If m, I and h is equal to 1, so now you have I and h. So if there exists only one uh, shop and that shop is same as d of j, then you are incrementing the list with m, I and h. If this is not true, then if length of j and h is equal to 1,
Sir,
and
can you please explain this with the help of an example?
so let's take an example. Say your matrix M. Tell me what number do you want? Let's say 0, 1, 2, 3, 4, 5. These are your j, and in 0.
Sir,
Yeah.
I'm sorry to interrupt, but like will you be extending the session, sir? Because I have
Yeah,
some
yeah,
more
yeah.
doubts to ask.
Yeah,
Please,
yeah,
sir.
no problem. Okay, 4. And suppose you have 5, right? Now you have 6 customers database. So each of them will have a list, right? Say for a case, M of, yeah. So this will be the row, right? This entire row, M of 0 when I say. Hello?
Yes, sir.
Yeah. So say let's construct a list. Suppose your M0, 1 is equal to, say, shop 1, shop 2, shop 3. Say then M0. So M You have IH, JH, right? So IJ. So one more element, right? So suppose 1, 0, 3. So shop 3. Say M 0. Shop 1. M 1, 2. Say shop 2. M 2, 2, 3. Say shop. Yeah. So with these cases, let's take a look at each one of these. Suppose these are the elements which you already know. For each of the I, so for I, we have say value. So it will be an empty list, right? For the first one, the second one.
Hello, sir.
Yeah.
So here, hello, sir. Here, like for the first one, M01, does it mean that the customer 0 and 1 they go to the shop 1, 2, and 3? Does it mean like that?
So what it means that for 0th row and first column, you have this list present here. This whole list. For 0 and 3, you have this list present. Only shop 3 is present. For 0 and 2, you have only this as a list. For M1 and 2, you have for M1 and 2 here you have only this list present. So we just are looking at one single case. Okay. So let's say for I in rows M, for each J in column M, for each H in row M. So if M of Ij, so if length of M of Ij, so say suppose for this particular case, right, for M of Ij, length is what? 3, right? Okay. Should it go inside the loop at all?
No, sir.
No, right? Suppose for M and H. So now H is what? Again the rows, right? For I is equal to 0, J is equal to 1, H is equal to suppose 0, right? For each of the 0, so I is equal to 0, 0. Is it equal to 1? It's an empty list, right? For 0, 0, M00 will be empty list. So this condition won't be true. J is your 1 and H is equal to 0. J is equal to
Yes, sir.
1.
How you did the second one?
Sorry, this one,
Sir,
right?
yes.
See, you're saying that M is equal to I. I is still 0, right?
Yes,
We are
sir.
looking at the first element of H. For each H, again, it is 0 to N, right?
Yes, sir.
So I is also 0, H is also 0. When both of them are there, it will usually be an empty list, right?
Yes, sir.
So length of an empty list will be 0 or 1?
0.
0, right? That's why this will get eliminated. So length of M, J and H is equal to 1. So now J is what? We said J is equal to 1, right? And H is equal to 0. So for J is equal to 1 and H is equal to 0. So 1 and 0. 1 and 0, we don't have an entry. Suppose this is your entry for 1 and 0. So this is shop 2. So this is equal to 1. This is equal to 1 and member D of I. So D of I was what? D of I is D of 0, right? D of 0 is what? Hello?
Yes, sir.
Yeah, D of I will be what?
It's for 0, no, sir. That is.
No, where is the D mentioned?
Sir, I think it's clear, sir. Because because I did not ask that out, sir. So I'm not sure.
Oh no, somebody else asked this out, no? Hello, who has asked this out? Hello.
Hello.
Yeah, okay, let's visit this. Okay, this will take some more time. Can we move to the next question? We'll revisit this if we have more time. Hello.
Okay,
I'll just mark this. Okay, graded assignment 10,
I
question number 10.
said 11. Okay.
Just give me a minute. I'll just note it
So
down.
practice assignment 8 question.
Sir, I have also questions from graded assignment 11, question number from 8 to 11, sir.
Just give me a second. Okay, what was it? Graded assignment 10, question number 9, right? Okay, I'll revisit this. Yeah. So what was the next question?
Practice assignment 8 question 2.
Sorry. Yeah, the following pseudocode. This is the one, right? Shopping bills data set. Let D be the dictionary that maintains the following information. The category of the item purchased by a customer. Choose the correct code fragment to complete the pseudocode. So D stores what? Item purchased category, right?
Categories.
Of the, the pseudocode. Okay. So
Sir, I think you can directly go to the options.
Customer name and the category is what it will store, right? Okay.
Yes, sir.
So you're going through. Okay, for each A in X dot item list. So D of X dot customer name and A is equal to true. If is key. Yeah, for each A in X dot item list, it will move through all of the items, right? In a particular card. If that item, the name and for that particular item, it will store it as a true. So what do you wanted to store? Category of an item purchased by a customer. Okay. If is key D and X dot customer name, D of X dot customer name is an empty dictionary for each A in item list. So what do you think is the correct answer? Hello?
Yes, sir. It's either C or D. That's what the option is given, sir. I'm not sure how.
Yeah, so
fourth option is the right answer.
Fourth is also right.
So I think fourth is the only right answer.
Okay, just take a look at it. Okay, when do you create an empty dictionary like this? Hello, you have an empty dictionary D. Okay, you are going through all of the cards. You are going through each of the card one by one.
Yes, sir. That I understood.
What you need to do? What you need to do is you want to store customer name. You want to store category also, individual category,
yes,
and you want to know whether it is present or not. Okay, so that is why you have boolean everywhere, true or false. That is what is being stored in.
Yes.
Right. So if is key D comma X dot customer name, if this exists, right? If the customer name, what do you call? Already exists, should it create a new dictionary?
No, sir.
No, right?
Like you have to
so
increment.
It should be not is key, right?
Yes, sir.
If this is not present, only then it makes sense that you should create a dictionary for that.
Yes,
That is
sir.
why this answer cannot be correct. What about the first one? It is only iterating through the
So
item list. It is
first
not
one,
yeah. So the first one won't be an answer. So either it is third or the fourth one, right? So if not is key D x dot customer name, what it is doing? It is creating an empty directory. Okay. Now else for each A. So if this is what do you call?
so for each chain, extra item list means A is iterating through each of the lists, right?
Each of the item list, but the issue here is that it comes in if and else statement.
Yes, sir.
If it is not, if the key
Okay.
is not present, it is creating it, right? If it is
So I think
already
that's something which
present,
I missed, sir. So
yeah.
if
So
this
it is
is there,
going in
then
the
for
else
each
block.
of the item we store, and
Yeah.
if the item is part of that category of A, then we
Yeah. So
give
you
the
need
value.
both of them in the block. It shouldn't be in the else block. That is what it is.
Yes, sir.
Yeah. Understood? Okay.
Yes, sir. Understood.
Week number 11, somebody said.
Yes, sir.
Question number? Practice
8
assignment, graded
to
assignment.
11. Graded assignment, sir.
Graded assignment.
8, question number 8. It has 4 parts.
Question number 8. Okay. Consider the following graph with 6 nodes. A is a 6 by 6 matrix corresponding to this graph. Assume that it has already been computed. In the following pseudocode, graph is a matrix, parents is a dictionary, and sequence is a list. Okay. And what it is asking, answer the question 8 to 11 using the information given above. In all question, S represents a list, P represents a dictionary, while A and B represents matrix. Okay. So what was your query in this? Just let me ask that first, then we will go one by one. Hello?
Yes, actually, I didn't understand this question. So please explain the graph and the
Okay.
question.
Okay. So how many nodes you have here?
5 nodes are there.
6, right?
6 are 6.
Total
0,
6 nodes
5,
are there. So it makes that the adjacency matrix should be 6 by 6, right?
Yes.
When it says A is a 6 by 6 matrix corresponding to this graph, means it's an adjacency matrix of 6 by 6 length. And it says that assume that it is already present. So whatever adjacency matrix come from this is already present. Now it is saying in the following pseudocode. So this is the pseudocode. We have a procedure called DFS. So you're doing depth first search. You're passing a matrix, a dictionary, and a list. And I is what? Hello?
Yes, sir. I will be all those nodes, no, sir.
Right. I will be each of the node, right? So, yeah. So sequence is equal to sequence plus I. Sequence is already is a list which is adding the value of the node for each j in column graph. So what do you mean by column graph? Graph is your matrix, right? It's an adjacency matrix. That's what they meant to say, right?
Yes, sir. So it will
Yeah.
be 6 by 6 matrix and
Yeah. So for each j in column graph, if graph ij is equal to 1 and not is key parents and j. What is parents? It's a dictionary. In the dictionary, what are you searching for? J. J is what? Each of the node, right?
yes, sir.
Right.
The
So you're
columns.
making sure in your parents dictionary, J's entry is not present. If that node is not present, and if graph of ij, what do you mean by graph of ij is equal to 1? It means that
There
if
is an
there
edge
exists
between
a
I
edge
and J.
between them, right? So
Yes.
first condition between I and j, there should be a what do you call it? Edge. And the other thing is that if in the parents dictionary it is not present, then we are adding I to the parents dictionary. That is what it is doing, right? and then parents and sequence is equal to DFS of, now it is recursively calling DFS for graph, parent, sequence, and J. Then you're returning parents and sequence. So it is returning you a dictionary and a list at the end of it. Okay. So in this particular question, what we know for sure, first thing is what do you call?
The graph
Yeah,
matrix of 6 by 6.
No, it's a recursive procedure, right?
Okay.
Right?
Yes, sir.
Second, just by looking at the code, it is recursively calling that, and it is feeding parents and sequence to the DFS. So what is the second? Yeah. So I is node, right? The procedure. Third will be yeah. What is the third? Answer question number 8 to 11 using the information given above. In all question, S represents list, B represents a dictionary, while A and B represents a matrix. What will the value of S after executing following pseudocode? P is an empty dictionary, S is an empty list, P of 0 is equal to -1, and P and S we are calling DFS for A, P, S, and 0. Okay. Can it be -1, the edge value? A, P, P represents a dictionary. Yeah. Always is.
Sir, what does it mean, sir, when it is -1?
I think it is setting the value of -1. -1 cannot be a value, right?
Yes, sir.
So what it is just initializing a value, some value for P of 0. When you pass it on to this
Okay, sir.
particular set of information, what is the output you are getting from this DFS? So you have to recursively call the DFS for A, P, S, and 0, this input. So like we said, 0 is your node number, right? What is your A? A is your graph, right?
Matrix.
Yeah, matrix. B is your.
So how do we know that, sir? Like, A is the graph.
If you look at your procedure, right?
Yes, sir.
The procedure, the sequence in which the arguments are passed, right? It has to be exactly the same, right? No matter what. So if I say graph is a matrix, so what your A should be a matrix, right?
Yes, sir.
If I say P is the second argument, P is a parent, parent is a dictionary. So second argument should always be a dictionary. Then the third argument is list. So the S should be
a list. Okay,
a list, right? And 0 is your node, just like we have
so
seen
can you
here.
please scroll up once?
Sorry?
Can you please scroll
Yeah,
up?
yeah.
No need.
Yeah.
Okay, sir. So I is the node here.
Yeah, I is the node. Sequence is
Then
storing.
what does the procedure say, sir? Like for sequence, we have to increment the value of.
So let's just go step by step. Let's say for this particular input, right? What it is storing?
Okay, if I ask one more query before getting to the solution section.
Yeah.
The above code. On the line number 6, why they are calling the procedure one more time, like calling the procedure inside the procedure?
Recursive.
It's called recursion, right?
Okay, but
so what you are essentially doing is that you want to recursively call till all of the nodes are exhausted. So for example, Have you gone through the content of week 11?
No, for me, DFS is kindly a kind of not understanding. I went through, that's why I asked you in the beginning.
No,
also,
like
to see
DFS
the
is one thing. Okay, this is depth first search, right? Algorithm. Okay.
So
But
this procedure DFS, is it related to the regular DFS, or here are we writing a new code?
so I believe that it should be the DFS procedure, what has been developed. But here, what we are getting out of the DFS is, parent and sequence. That is what the return value we want
So
from it.
parent is a dictionary and
So
sequence
parent is a
list. So
dictionary,
we're going to
sequence
have
is
a
a list.
dictionary and list.
And a list as an output
Okay,
by giving these inputs. So what question I asked you is recursion is different. Recursion, I think this is also covered in week 11, right?
Sir,
Yes, sir.
so what
Or
is
week 10?
EJ in columns of graph? Does it also represent the node in line 3?
Sorry, line 3?
EJ in columns of graph. Does that also represent a node?
So yeah, you are going through each of the node which is present in the columns, right?
So and if
For
there is
a
edge between
matrix,
I and J,
so yeah, so for graph of I and J, if there is an edge present, right, it will be 1, right?
Yes, sir.
Otherwise, it will not. If it is present, then we are testing for this also, not is key parent and J. If both the conditions are met, only then we are updating the value of the parents dictionary. Okay. So yeah, so back to the question you have asked, right? Recursion.
So the not is key parents of J. Does it mean the node must belong? Should be a part of the dictionary. So the node. No, sir. Can you explain the not is key statement? What does it stand for?
So what is your parent? Parents is your dictionary, right?
Yes, sir.
What does this dictionary stores in? Do we have any information regarding that in here?
No, sir.
No, right? So just let's assume there is some dictionary which is called parents. This
And
dictionary,
J must be a key in the dictionary.
Yeah. So J should be a part of that dictionary. If it is not, only then it will
It should
go
not
in
be
the
a
loop.
part of the dictionary.
So for each of the node which is present in the columns, right? If it is not part of the parents dictionary, it will
take it as one.
it will make it as 1. Right? For that particular J node, you will have I as an entry there.
Yes, sir.
So for that, there has to be an edge between I and J. Only then it is, incrementing that. So yeah,
Yes,
so
sir,
back to your question, right? So can anyone explain what recursion is?
So like when the procedure is again called inside the procedure, no, sir?
Yeah. So I think in factorial example, in the lecture, it has been covered what recursion is. Essentially, how do you calculate the factorial? Because I want to calculate 3 factorial. Yeah, how do you calculate 3 factorial?
3 into 2 into 1.
3 into 2 into, sorry, 3 into 2 into 1. Sorry, 1. This is how you calculate 3 factorial, right? So if I write a procedure called, factorial, and pass it a number. So if I want to calculate the factorial, what should I do? Hello?
N minus 1 first. I mean, we need to take the values of n into n minus 1, and again we need to multiply the same value with another n minus 1 until it turns 0.
So how will you do that step by step? If I say that you need to find out the n factorial, what is a non-recursive way to do that?
The value of n is 0, not 0. I as 0, we can call a variable I as 0 and you can say, yeah, if n is equal to, if n is equal to not equal to, I mean, if n is greater than 0, n is greater than I, I'm sorry, if n is greater than I, then n inside the bracket, okay, the true condition will be n is equal to n into n minus into n minus 1, n minus 1 inside the bracket. Yeah.
Like this?
Yes.
But how do you know when to stop?
No, that's what, if n is greater than I.
Anyone else? Hello? So, yeah. For i's, for n is greater than 0. Yeah, what should we do? It's equal to,
If n is 0, we'll have to return 1. Otherwise, you have to return n into factorial of n minus 1. So it keeps iterating that way.
yeah, so how do you do that? For
So
n is greater
procedure
than 0.
factorial of n, I have to say if n is equal to 0, return 1. Else return n into factorial n minus 1 n factorial.
Yeah, no, but factorial you need to calculate, right? By multiplication. How
So
will you
we
say
can,
that return n factorial?
so we can initiate a variable with like fact equals 1, and then we will, for any n, we can multiply it with fact, and in the next line we can write like n equals n minus 1, and the procedure goes on.
Fact into?
So factorial will be 1.
Fact into n.
Yes, sir. So in the next line, n
So it
equals
will be
n minus
factorial is
1.
equal to factorial in tensor because we have to increment the factorial only.
Yeah, then fact is equal to
I
fact
think
plus
of
1.
while n is greater than 0, factorial will be factorial into n. Because for example, we begin with 5 and we multiply 5 into 1 is 5.
Like this?
Then we have to reduce the value of n. N is equal to n minus 1. So then it will again come back here and multiply, for example, 5 factorial 5 into 1, then 4 into 5, 3 into
Yes, sir.
20, that is.
N factorial is usually calculated as n into n minus 1 into n minus 2 till 1, right?
Yes, sir.
Yes. So I
This is
think
what
this
we
was
want to do.
explained in one of the sessions, like open sessions, the instructor.
Yeah, so basically what recursion, like when you are trying to calculate this, right, it becomes so tedious that you need to form a sequence, like you need to know when to stop. In such a scenario, what they do is essentially they recall the same function in this, like what she said right before just now. N is equal to
n minus 1, so because we have to keep decreasing the numbers.
n into factorial of n. In this scenario, what is your base case?
Factorial n.
N is 0, sir, then we have to return 1.
Yes. That is the most important scenario, right? So
Yes.
if n is equal to 0, what do we have to do? Return 1.
Return 1.
Return 1. Right? So what's the next case? Else?
Let's return n into will be the factorial of the n previous up till the previous number.
So I can just say, sorry, return what? N equal to factorial of n or n minus 1?
So n minus 1 would be there.
Right?
Yes, sir.
That is it, right?
Yes, sir.
Sorry. So what essentially, who asked this question? Recursion?
Me, sir.
Yeah, so what you really need to know is that, right, in some of the cases, you cannot calculate, it is better to calculate, whatever you want to find recursively, when you know a clear cut of a base case where you know that we can get out of the loop. Suppose we never had this f n is equal to 0, return 1. What will happen to this loop if we just put return is equal to n into n factorial?
It will not end up.
Stop, right? It may even go to negative side, right? Also, right? But factorial is only up to 1, right? This is your end. So in cases where you know that where it should be stopped, and recursively we can call it till that point, is where usually recursion function is used. This technique is used of recursion. So in DFS, usually it is used because if you know DFS, right, in this particular case, what DFS means, depth first search, is it is used for detecting the what do you call, like the connections between the nodes, right? In this particular scenario, suppose you want to know how the nodes are being connected from 0 to whatever end node there is, right? So there are two ways you can do. Either you can follow one node to another node to another node to another node and keep following till you figure out what all connections each of the individual nodes has, right? Or otherwise, for each of the node, you see how many connections there are and then count those. Then again, go to the next node, see how many connections it has. So that other process is called the depth breadth search, the BFS algorithm. In DFS, what you see is you look at the first node, see which one it is connected to. Now in this scenario, 0 is connected to 1 and 3, right? Take the first one, whichever it is. It can be 1 or it can be 3. If I go to 1, I know from 0 to 1 there is an edge present. Okay, from 1 again I will go and I'll ask whether there is an edge present between 2 and 4, between which of the next node. So one is connected to 2 and one is connected to 4. So if I go from 1 to 4, I'll ask the same question again. Which all nodes the 4 is connected to? I see it is not connected to any of the other nodes except the one which we have already visited. So we cannot proceed further. In such a scenario, we take a step back, go to the node 1, and again we ask which of the other nodes we haven't visited yet. So we know that 2 we haven't visited. So from 1, we will again move to 2. At 2, we will again ask which all nodes we haven't visited yet, which all it is connected to. So it is connected to 5, 3, and 1. So the algorithm will ask, take any one of the path. Okay, either you take 5 or you can take 3. 2 is connected to 5, it will go to 5. Again, at 5, you see that it is not connected to any of other nodes. It is only connected to 2. In such a scenario, you have to backtrack. You have to go back and go to again 2. Again, ask the same question, whether all the connections to the 2 has been visited before. In this scenario, it is not, right? We still are left with 3. Okay. So from 2, it will go to 3. At 3, it will ask which all other nodes we are connected. 3 is connected to, and which all nodes we haven't visited yet. So we have already visited 2, but we haven't visited 0. So from 3, it should go to 0. Again, ask the same
So
question.
are you just explaining the depth first search and
Yeah,
the breadth first search?
DFS.
Yes, sir. Depth. Like you
Because
haven't
in
started
breadth
explaining the
first,
question, right?
yeah, in
Yes, sir.
DFS,
That concept I'm clear.
yeah, for BFS we have to count all the nodes, right, for each
Yes, sir.
for which it is connected to. In depth first
Sir,
search, you just
hello, sir.
proceed through. Yeah.
From the node set 2, first of all, it will go to 3, sir, no? Not 5. From 2, because it will go to the nearer one, like 3, 4, 5. So it will go to 3, not 5. Right, sir?
See,
From
the
2, it can go to 5 or 3. So now the question is, it will go to 3 because 3 is nearer to 2. Is it like that in DFS?
No. How do you compute whether it is nearer or farther?
Because from 2, next one is 3, sir.
No, you are looking at it numerically. Suppose I had, just random name given to it. Don't look at it as an, because it starts from 0, 1, 2, 3, 4, 5. This is not how it usually works. All you need to know is what all nodes it is connected to, each of the node. Ask the question whether we have visited all the nodes present in there or not. If it is not, then we move to the next node. You can have a criteria, like in this scenario, if you know that 0, 1, 2, 3, there is a sequence to it, you can have a criteria. But the point here is that the criteria doesn't matter in DFS. All you need to know is that 2 is connected to 5 and 3. You can take a you can have a choice whether to go visit 5 or whether you can go and visit 3. In any case, even if you go from 2 to 3, it will go back again. It will ask again the same thing, whether it is which all nodes it is connected to. 3 is connected to 2 and it is connected to 0. So 0 we have already visited, right?
Yes, sir. So it will not
So
go.
it will go backtrack and again it will ask the same question. Have you visited all the nodes?
Okay.
We haven't visited 5. So it will go there. Again, it will ask the same question, whether we have visited all the nodes which are connected to it. If it is, then it will backtrack. Again, at 2, it will again backtrack, see which all nodes we have already connected. So at 1, if we haven't visited 4, it will visit 4. Otherwise, it will go back and backtrack again at 0. Okay, till all the nodes are visited. That is what DFS algorithm is. So in DFS, it is important that you need to backtrack also, and you need to know whether it is connected to the node or not. So given this information of DFS, what do you think the graph matrix is storing, what parent dictionary is storing, and what sequence list is storing? Hello?
The sequence is storing the list of nodes.
So what are you explaining now?
No, I'm asking just by knowing what how DFS works.
Yes, sir.
A is a matrix, right?
Yes, sir.
6 by 6 matrix. We have total 6 nodes.
Yes,
and
sir.
it is already been computed, and it tells you this information that whatever graph, it is a matrix, whatever
Yes,
parent
sir.
is, it is a dictionary, and whatever
So explain this, yes, sir.
is a list, right? So I'm
Yes,
asking,
sir.
you understand what matrix is storing, what dictionary is storing, and what list is storing?
So matrix is storing the rows and columns as nodes, and if there's an edge between them, it stores 1.
So it is storing the information regarding the edges, right?
Yes, sir.
What is parent storing?
So dictionary.
Yeah, what does the dictionary
Does it store the number of edges each vertex have?
Is it number of edges or it is number of nodes?
Like for example, 1 is in connection with 3 and 4, it stores 2.
Just take a look at this, okay? So for each j in column of your matrix, right? If there is a connection
between the nodes, the key will be the nodes.
Yes, right. It stores the value. It is storing what? Nodes, right?
Yes,
but
sir.
This node is storing what? Again, it is storing I. I is also a node, right?
Yes, sir.
So what does this parents dictionary storing?
It's storing each of the nodes and
which are connected, right?
And the connected nodes. Yes, sir.
Right? Pair of nodes which are connected, right? That is what it is storing, right?
So, like, for example, 1, 2, 1, 3, and the keys can be repeated, sir.
Hmm?
Can the keys be repeated?
Is key, you mean to say?
No, so like J parents is the dictionary and nodes are the keys. What will be the value of the keys?
Value of the keys is the connection information, right?
Yes, sir.
So
and that is also a node.
It's also a node.
For example,
so whether between the two
a
nodes,
vertex is not connected to 2. For example, here 3 is connected to 0 and another node. How do we store that?
no, come again.
Yes, sir. In this graph, 3 is connected to 0 and the other node, other vertex 3 and 2. How is it stored?
So let's take an example of 3. Okay. Now
Yes,
I'm
sir.
passing 3 here. I have
Yes, sir.
passing graph, parent, and sequence, whatever it is. Sequence we are incrementing. Okay. Now the sequence will
sir.
have 3 in it. Okay.
Yes, sir.
For J in column graph. Okay.
Yes,
now
sir.
we are looking at columns. Okay. It can be anything, right? For this
Yes,
case,
sir.
what the value of J will be 0. It will be from 0 to 5, right?
Yes, sir.
Say, for example, 0. You take first 0 as your for 0 in column graph. Okay.
Yes, sir.
If 0 and 3 is equal to 1, is it 1?
Yes, sir.
0 and 3, it is 1.
Yes.
There's a
And
connection.
is key parents and J. So suppose this
No.
parents dictionary is empty for now.
Okay. If the 3 is
If
the
it is
first time,
empty,
it shows you. Okay,
yeah.
sir.
J is what? J is 0, right? In our first
Yes,
context,
sir.
right? So in parents, J is not present, right? So what we are saying that
Then the value will be
dictionary, yeah,
3.
parents
1.
of 0 is equal to 3.
Yes, sir.
That is being stored, right? If
Yes,
there
sir. Yes,
exists
sir.
a connection between 0 and 3, the parents is storing that information.
Yes, sir.
So again, it is calling parents sequence, and it is again calling this function recursively. Now sequence has what? Only 3 in it.
Now it will
stored,
be,
right?
yes, sir.
What sequence has?
It's a list of the nodes.
Yeah, sequence has only 3 in it. Parents has the information 3 and 0, right?
Yes, sir.
That information is again passed through graph, parent, sequence, and J. Okay. Now your
Yes,
graph
sir.
is all the information regarding ages. What your parents have now? Only information that
0 and the value is 3.
yeah, 0. The value is 3.
Yes,
okay.
sir.
What is the sequence? Sequence
Just
has
3.
only 3.
Yes,
and
sir.
J, what you are going to pass?
Next 1.
Is it 1?
0.
J is 0, right?
Yes, sir.
Now you are passing 0 into it.
So graph will be the entire graph, right?
It is entire graph. Okay. This
Yes,
is
sir.
not changing. What is
Yes,
changing
sir.
is your parents and sequence. Now you have
Okay,
passed
sir.
on information of J. J is 0. Now that J is 0,
Now the sequence will include 3 and 0. Okay, sir.
3 and 0 into it, right? So
Then for
let's
this-
just type it out.
Sir, I think I'm able to understand. I'm not sure about like.
Yeah. So what you said, we started with 3, right?
Yes,
so
sir.
your sequence has only 3 in it now.
3, yes,
right?
sir.
And then your J value, your I value is equal to 3 and J value is equal to 0, right?
Yes, sir.
Now we are saying that if between I and J, that is between 3 and 0,
Yes, sir.
there exists 1. So it exists 1 because we know that they are connected.
Yes, sir.
And
Like, sir, I've
it is not.
understood
So-
that, sir.
No, just we can go to the next step, how
Okay,
the
sir.
recursion is working. So parents of what? Parents of 0
0 will be.
is equal to 3. This is the
Yes, sir.
information we have now in parents.
Yes,
And
sir.
now we are again sending the parents and sequence information. So we are passing these two values. So now the sequence will be this value and parents will
graph
have this
and
value,
the parents, the
and
sequence
graph
and
is
0.
what yeah, for all the information which is already present, right, regarding the
Okay, sir.
connection. And now what the J is we are passing
Will be
to
0.
0, right? Now
Yes,
new
sir.
I will be 0, right?
Yes, sir.
Then sequence will become 3, 0, right?
Yes, sir.
So now what J will be? j can be 1, right? Because
So we'll
3
have
is
to
all,
take any random j, sir. Like,
yeah.
okay, sir.
Suppose you take 4, right? This is not present, right? So will it
So
go
it'll
through all of
anyways
this?
not go there.
Right? It will only go, like, this loop will only execute when
If there is a connection between them.
there is a connection between them, right? So 0, 4, 2, 5, there is no connection.
Yes,
0,
sir.
3 is already present, right?
So next
If
one.
it is present, it will always, this connection, this information will be wrong, right?
Yes, sir.
So it will not go into it. So the only possible place it can go is 1,
Yes, sir.
right? So now j is equal to 1.
J is 1.
So you tell me what, now graph I and j. So between 0 and 1,
There is a connection.
there is a connection, right? And is it a key in parents?
No, sir.
Right? We have only one key here, right? We don't have information on parents.
Parents and 1 will be
One
false.
is not there. So what it will be?
True.
It will be I, right? What was your I now?
J is 1. Parents of 1 be 0.
Yeah, I is your 0, right? This is your
Yes,
second
sir.
iteration,
Yes, sir.
right? Your I is equal to 0. So new entry to your parents dictionary is added, right?
Yes, sir.
And then
So
again, we
parents
are
of
passing the same
1.
information to the same procedure.
Yes,
Right?
sir.
Now we are going into the third iteration. Again, what I possibly can be, I can be 2 or 4, right? For this condition
Yes,
to
sir.
be true, right? So if
Yes,
suppose
sir.
we say I is equal to 4, what will be the sequence? 3, 0, and 4, right?
So the next time we're taking IS4.
Yeah.
Okay,
Because
sir.
out of all the connections, the connection is only present between 2 and 4, right?
So won't it be 3014? Because you're already gone through it.
Yeah, sequence was already, the sequence 30 is passed again, right? In this command.
No, so
The
like
parents,
parents of 1, parents will be 0 is to 3, 1. Then sequence will be 3, 0, and 1, right? And J will be 1.
yeah, 30. Sorry, did I make mistake here?
So sequence is 30, J is 1. So parent of 1 is false. So we are going parent of 1 will be 0.
No,
Parent
parent
of
1
J
is 0, j was equal to 1, right? In previous one.
So what will be the, so well, parents of sequence line 6 will be
So
DFS
new j
graph.
will be 1, right? New I will be 1. Correct?
Sir, I will be 1. And,
because your, in this scenario, your j was 1, right? So the value which was passed in here will be 1, right? We are going here. True or false?
so initially the I value was 0, J was 3. Then J became 3.
So
Sir?
you just look at the, hello?
Yes, sir. So when we entered the DFS, means line number 6, we like updated the value of I to J, right? It became 3. Now we were checking for each J in columns. So why not we took the value J to 2?
No, we can take j is equal to 2. That is not a problem. See, if you take j is equal to 2, is there connection between, so in this scenario you're saying, right?
Yes, sir.
Yeah, so we are at 0, right?
Yes, sir.
So is 0 connected to 2?
So when like we have entered the DFS as 3, na?
Yeah, we entered as 3, then we moved towards the left at 0. Either you can move to 2, you can move to 0, right?
Yes, sir.
Yeah, so in my scenario, for each j, right, I consider first j should be 0.
Okay.
In all the columns, I assumed 0 to be the next entry. After 0, the next entry, I assume it to be 1.
Okay, sir.
Understood? From
Yes.
that sequence I'm going. So if we are going in that sequence, what I was asking, yeah, for if previously in the first iteration, right, our I was 3 and j was 0, right? We assume j to be 0. So we pass that j as I by using this recursively, right?
Yes.
Yes, right?
Okay. Yes, sir.
Right. In similar sense, if we move to the next sequence, right, this j now was 1 will become next I, right? So
Yes, sir.
I will become 1, and in sequence you will have 3, 0, and 1, right? Because you are appending your sequence list, correct?
Yes, sir.
Right, because you recursively calling the same function again we are appending I, again we are looking for each j in column graph, right? So we are going through each of the column in the matrix, so assuming that the next one is 4, or next one can be 2 also, not an issue, but we have to make sure that there is a connection between them, right, between I and j. I can also take I as equal to 5, but the issue is that between 1 and 5 there is no connection, right? So this condition will be true. This condition will be false. So it will not enter into this if loop at all. And it will just return what the parent and sequence is. And it will again iterate for the next j, right? So the next j either can be 2 or 4 because it is connected to 1. Because in the matrix, you will have an entry of 1 for each of the connected node. That is why we took uh, the previous one. We took the value of j as 1 because 0 was connected to 1. Now we are taking the value as 4 because 1 is connected to 4. So suppose j is equal to 4 in this scenario. And so if j becomes 4, there is a connection between I and j, and it is not a key yet, right? Is it a key in the parents dictionary?
No, sir.
No, right? We have only 0 and 1. It is present, but 4 is not present. So what parents dictionary will have again? For j is equal to 4,
Value will be 1.
1, right?
Yes,
We
sir.
have this entry into it. Then again we are passing it to the next one, fourth. So is 4 connected to anything else apart from 1?
No, sir.
No, right? Now 4 is connected to 1, right? That is what we know. So what will be your new I? 4, right?
Yes, sir.
What will be your sequence?
3, 0,
3,
1.
0, 1, 4.
3, 0, 1, and 4, right?
Then 2 and 5.
Yeah. So now J is connected to only 1, right? This is the only connection it has. It doesn't have any other connection. So
Yes,
Yes,
for
sir.
sir.
all of the J's, the values will be 0, and it will not meet this condition. So we have to go and backtrack to 1.
Yes, sir.
So again, your J will become 1. If J is
Yes.
1, tell me what will happen to this code. Now your J is equal to 1. Will it go inside and update the value of J? Hello?
Sir, J is
Yes.
1 or I becomes 1?
Sir, I think
So because the value of 4 is of I, no? So if we have to proceed ahead, we have to change the value of I.
Yeah, no, you have to backtrack, right?
Yes, sir.
You, because there is no connection between 4 and any other except 1, right?
Yes, sir.
The only option where you have a 1 and 4, there is a connection, is only this one. So only
Yes,
for that one, this condition will become true,
yes, sir.
right? That is why we are backtracking. Suppose we
Yes.
backtrack, we are at 1. Now we know that. So that is why your, your
Okay.
last J was 4. So your I will become 4. Your sequence will become this. Now your J will become 1, right? Because you have backtracked.
Yes, sir.
Correct.
Yes,
Now
sir.
I want to ask you, is key of parent and J, is there a key for parents 1? Is
No,
there a
there was
key?
no.
Is there, right?
Yes. Hmm.
We had it, right? Is
Yes, sir.
0. So there exists a key. So should it enter into this
No,
if
sir.
loop? No, right? It should go out again.
Yes,
And
sir.
again, it will return you the parents and sequence, right? This is where it will end, right? Will it?
Yes, sir.
So how will you make sure that it is actually visiting all of the other nodes? You only visited 3, 0, 1, and 4. We are yet to visit 2 and 5.
Sir, I think you can go to the question, sir, because
Yeah. So what
the
was the
concept
question?
is clear.
Hmm. So no, the question is depending upon that, right? What will be the value of yes after executing the following pseudocode?
So I think you have to, for it, start from 0 and check each of the options.
So we started with all the empty dictionary and empty list, right? And P of 0, we assume it to be -1. In this particular example, P of 0 is what? P of 0 is -1. That is what is initialized. So just take a look at this example then. Okay. P comma S is equal to DFS of A, P, S, and 0, right?
Yes.
So you have uh, A remains the same, right? A has all the information regarding the connection, right? So the graph matrix remains the same. What is being passed? P and S is being passed, which is empty. So your P is an empty dictionary and S is your empty list, right? So P and what? If P of 0 is equal to -1. Okay. And your I is equal to 0, correct?
Yes, sir.
Okay, now let's
Yes,
look at
sir.
this. So the sequence, right? Let's see. So what will the value of sequence from empty list?
0.
Yeah, it is an empty list, right? Because that is what is being sent to this particular function, right? We are sending an empty list, but we are going to add the first element. First element was 0, right?
So I think it is similar to what you explained with 3, sir.
Yeah.
But
So in
I
this
think you
case,
can
it
do it.
is 0. So now you do J. Now J was what? All of the columns in the graph, right?
Yes,
If
sir.
ij is equal to 1, is the ij equal to 1?
So what did we select next after 0?
So G after 0, you can select any. J can
And
be
sir, like
any.
for
So
example,
suppose
1, sir, because there's
1
a
is
connection with
your,
1.
yeah. Suppose it is 1. Let's go one by one. Okay.
Sir, I
So
think it's very
say,
similar to what you explained with 3, sir.
yeah.
Because you
So
also have to revise for the exam. So to
mhm.
do it faster, it will be easy.
Yeah. So this is what it is now. You really have to go through step by step in each of it. But what I wanted to ask you, what does this signify? P of 0 is equal to -1.
So it will be the value of the
Initial.
0.
P of 0 is equal to -1 is what is being sent to the procedure, right?
Yes.
So anyways, if you guys can understand this and go step by step, I think you will be able to figure it out. The point is here,
Yes, sir.
it goes recursively. So every time you have to look at this connection diagram, or you can write down your own matrix just by looking at this connections, your 6 by 6 matrix, and then feed that and do step by step process. So what do you think in this scenario will be the output? Just by looking at DFS, I'm not asking anything. If you're starting at 0, right, what will your
So it will
sequence
be
will be?
0, 1,
Uh,
2, 5, 3, 4.
0, 1, 2, 5.
0, 1, no, sir. 0, 1, 2, then 3, sir.
0, 1, 2,
1,
3,
2, 3, then 5, then coming back to 1, then 4, sir.
4.
Oh, so it is based on, numerical order.
No, just
Yes.
take a look at this. What do you call? So what all options you have?
Actually, sir, it looks like how we investigate in case of DFS. The nodes, how we explore, find out the sequence of the nodes. So that is what we have to find out.
Yeah, but let me ask you one question. In DFS algorithm, you should revisit all the nodes, right?
Yes.
Yes, sir.
Yes, sir.
So is option 2 visiting all the nodes?
No, sir.
No, sir.
Is the last one visiting all the
No,
nodes?
no, sir.
Out
1
of
and
these
3.
two, do you think which one makes sense? Where do you think the backtracking will happen? So you have 0, 1, 2, 5, and you have 0, 1, 2, 3.
I think 0, 1 to 5 can also work, right? Because 0, 1 to 5, and then you backtrack to 2 and then to 3.
So what?
And then to 1 and 4. But
If
why
you
do we
go
have to take
0,
3
1, 2,
first?
5, 3, and then 4. Yeah. Tell me. 0, 1, 2, 5, 3, and 4. 0, 1, 2, 5, 3, and then backtracking to 4. And the other option is
0, 1, 2, 3, and then 5.
So in the first option, we have to backtrack twice.
in the first option.
Yes.
0, 1, 2, 3, backtrack once, again 3, backtrack, again one more time, and then 4.
So I think it will be the same only, sir. It does not make much difference. But
Yeah.
But
So
sir, I understood, sir, like when we have to explore the the neighbors. In that case, the node which is closer to that the parent node that we have to visit. Like as already I have said, suppose if we are in the node 2, then from there we can visit 5 and 3. So 3 will be 3 we have to visit first, sir. Then we have to go to 5. That is what I understood from the class
So
answer.
let
Okay,
me
sir,
ask
got
you, in the class, if I give you all the cities name instead of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, you don't know how far these are. You just have this connection information. Will you be able to draw the same conclusion in
Sir,
that
that's
case?
what, sir. BFS, we can have multiple trees.
Answers,
That's
right?
what it says. Yeah, multiple corresponding DFS trees.
But what it is asking you is the list, not the DFS tree. Again, you are mistaking it. What it is asking is what the sequence will be, right, at the end of the execution.
Okay, sir. I think like what she said, what sir, I think it's one closer to the parent node. I think that logic might work out here.
Yeah, so this is where you really have to go through the scheme of the things, because the only difference between these two is what it is not asking you the tree. It is asking you how the sequence will be. So in that scenario, you have to go step by step and see why one of this option is true. So in this scenario, you can use that logic, whichever is the nearest one given the numerical order. In that sense, it can be said that it is nearer and farther. But if that is not the case, if you have given a very random numbers, will you arrive at the same conclusion or not? That you can only see from looking at how it is traversing and how the entries are being made to the sequence. That is what I am trying to say. Okay.
Yes.
Yes.
In case of 9, again the same thing here will also happen.
Yeah.
It just, if you start at 0, what will be the output of the list? What if you start at 5, what will be the output? So you
Yes,
have
sir.
to go each of the cases one by one, and at the end it is what it is asking you.
So it might work out, sir, but it says cannot be determined as the answer.
Which one? In
Maybe
this,
the question is different or something, because it's
what will be the value of the nodes after the execution of the following pseudocode? So you are not only passing this, whatever output you are getting it from here, you want to know the nodes. Nodes will be a list, right? Keys of P. So do you think there is only one way DFS will go? from 5?
No.
In DFS, if you have looked at the examples, right, the tree examples, there can be multiple ways it can traverse through. So just by giving the information of the keys, right, you cannot determine which of these is actually a true case unless and until you traverse through all of it. There cannot be one single answer to that. That is why it cannot be determined should be an answer in this scenario. So
Yes,
just go through this. I think we are already out of time.
So from practice assignment 11, can you just explain question 1?
Practice assignment. Yeah, okay. Question number 11.
1, sir.
1. Okay. Unique is a process that accepts a list L as an input. It runs the unique element in the list after removing duplicates. Select the correct code fragment to complete the pseudocode. Okay. Okay, so you need to find unique.
Yes, sir.
Yeah, unique entries in a list. The procedure, it calls for an empty list. Then if length of L is less than or equal to 1, return L. Otherwise, init element is equal to init L, and then fill the code. What does init do?
It removes everything except the last. It removes the last element.
Right. Except the last, all of the other elements will be
returned.
present. Returned. Right. Okay. So if member of init element last L, return unique. Yeah. So tell me, what should be tested first? If you want to find a unique element, right? What should be your logic? So if you look at all of the options, right, you're testing for member, and member.
And then you return.
So what does member tells you? What it returns?
From the init element, the unique means those which are occurring only once. Like, does it return all the elements?
Your init element is an init L. So it is list without the last element, right?
Yes, sir.
Yeah. If member init element last L, what does this mean?
If in the list, sir, if the last element of the list is a member of
Init list, right?
It's a member of init element list.
Right. That is what it is testing.
Sir.
And what output will it give you? It will just give you true or false, right?
So return the init element. What does unique first?
No. I'm asking, what does members init element last L will
either true or false.
Either true or false, right? So if the one of the element, which is the last in this case, is a member of init element or not. If it is a member,
initially it is it is not, because it is an empty list.
Init element is not an empty list, right?
Yes, sir, it is.
No, init element is started with an empty list. It says that if the length of L is less than 1, return L. Otherwise, what it is saying, init element is assigned as init L, right? So it is not an empty list anymore, right? So when you enter into this code, this is not an empty list. It is an list with all the first elements, right?
Yes, sir.
Except the last one. And
yes,
you are
sir.
comparing whether the last element was a part of the other part of the list.
Yes,
if
sir.
it is so, it will return true, right?
Yes, sir. Yes.
Only in that scenario it will return true, and it will return unique init elements. Is it true?
No, sir. Like if
it is a member, should it return unique elements?
So if it is a member, it will return unique elements.
So if I say the last element of L is a member of the rest of the L, right? That means you have a duplicate, right?
Oh, okay, sir. Yes, yes.
Only then it will be true, correct?
Yes, sir.
That means when it is true, you are returning it as the
last of element must be the first of the element.
No.
Okay,
do you
okay.
need
So
to
there's
check?
a duplicate in the init cell.
There is a duplicate in init element,
Yes, sir.
right? So this is not a unique list
Okay, sir.
in any sense. What is else doing here? Return unique elements plus plus last L.
The entire L.
Yeah, so entire L. So when it is returning entire L,
When there is no,
it is not a
the
part of this
last of
member.
L is not repeating, is unique.
Yeah. So then it is returning entire list, right?
Yes, sir.
So where it is going? The return list. This is recursive calling, right? Hello?
Yes, sir. Yes, sir.
You look at it here, right? So you see
I've
here,
understood the code
it is recursively calling it till all of the element probably
because it's within the procedure. Yes, sir.
The procedure is calling itself over and
Yes,
over
sir,
again
got
in the return statement itself. Same is true in here. Is it true in the second scenario? No, right?
So I think the second one cannot be true
Why?
because it just returns init of elements and
It is returning init of elements. It doesn't necessarily mean
but
that
not the
rest of
unique.
the list doesn't have any of the duplicates, right?
Yes, sir.
Ideally, what it should do, it
Sir,
should keep on
so
reducing
what is the difference between unique init of elements and just returning init of elements?
your procedure itself is called unique, right?
Yes,
For a
sir.
procedure unique, you're passing a list.
Yes.
When you are returning init element to a unique, you're returning the list without one element into it, right?
Okay, sir.
Right. You're recursively doing it till your length of L becomes 1, basically.
Okay, sir.
This is your base argument in the recursive calling, right?
Yes, sir.
This is where the loop will stop. But it will check for each of the element till all of the elements are exhausted. Till so that is
Yes,
why
sir.
your unique is important. You're calling yourself again.
Okay, sir.
The function calling itself again. So out of these options, do you think which one is most appropriate?
It cannot be 2 and 3.
Why?
So because it does not recursive.
It is not recursively calling, so it cannot be 2 and 3. What about first and last? Let me reduce. What it is doing? If init element
I think
last
here,
L,
no, sir.
return
I
unique
think in the
elements.
first one, here it is returned as a list or something. The member of the list, because you're appending to a list, whereas I think in the fifth line of the first option, it's just trying to include an element.
That is the only difference between the two.
Yes, sir.
So which one do you
In
think
the
is
first
the
one,
correct?
it's not a list.
Sorry?
In the first one, it is not a list, no, sir. Last L. In the last option, it is list that the bracket is there, no, sir. The third bracket
Yes,
is
sir.
there.
This one, no?
Yes.
Yeah,
Sir.
third bracket. In the first one, the first bracket is there.
What
In the
does unique
first option.
return at the end?
I think the entire list. If there are only the unique elements of the list.
No, init element is a list, right? In itself.
Yes, sir. All the elements in the list which are like it returns all the elements in the list, but only once. Yes, sir. Got this one.
Okay, I'll stop here for today. Okay.
So
the mock assignments, can you explain, sir?
It's already.
So here the option is 4, right?
Let me just quickly check. Why do you think option 4 should be right?
No, sir, that is the last value is appended, no, sir, with the list.
So
Yes,
in
so
a
the
list,
last is appended as a list to a list,
you
but here
cannot
I
append
think as
an
an
element
element
to
is
a list.
trying to be included.
So which one is correct?
Last
Because
one.
there's a difference only in the fifth line, otherwise it's only.
Yeah, understand.
Okay. Okay, so mock testing is end term, huh?
Yes, sir.
Which question? Question number?
Yes, sir. I'm just taking it up 1 minute. So question 14.
Yeah.
Yes, sir, I've understood everything. I just would like to know the incorrect lines are line 5 and 21. You could say why those are incorrect. I have
Not member. Okay. Member, can you, it should be is key, right? D is a dictionary or is a list?
yes, a dictionary.
Dictionary, right? Member is a function on list or dictionary?
Which one, sir?
Member. See, you said you don't understand why there is an issue with the line 21, line 5, right?
Member is for a dictionary.
Member is for dictionary or member is for list?
Member is for list and this key is for dictionary.
Dictionary, right? That is why this is not correct, right?
Okay, sir. I think that's where I got confused.
What about this one?
So that one I'm not sure.
Says incorrect conditional statement. Is it? What it is trying to do, the program? The following pseudo-code is executed using shopping tool. At the end of the execution, L stores the list of distinct shop names, which only one category of item has been bought. But the pseudo-code may have mistakes. And if I search mistakes, if any, okay. If not, is key returns what? Hello?
Yes, sir.
Is key returns what?
Whether the key is part of, whether the dictionary has a particular key.
Okay. Suppose you have that shop name, right?
Yes, sir.
Shop name exists in your dictionary A.
Yes, sir.
Right? So is key should return what? True.
Yes, sir.
So when it
if
is
not,
true,
if suppose the shop name is not a part, is not a key of the dictionary, then it will be true. Then we have to update.
if not is key means it has to be false, right?
Yes, sir.
Yes, sir.
When it is false,
Yes.
When the shop name is
when
not a
shop name
key in
doesn't
the
exist
dictionary.
in A.
Yes, sir.
So is key is false, not false is true. So
Yes, sir.
when the shop name doesn't exist, you have to update A comma X. So what does
Yes, sir.
update do? It takes dictionary, it takes Y. Y as in your shop name. So the following pseudo-code at the end of the execution L stores the list of distinct shops with only one category of items have been bought.
Sir, I think it should be is key, sir. I just gone through like if is key, like.
No, what is it? It is related to your question itself. You just tell me what this should find. This program should find.
Like the shops.
At the end of the execution,
no, sir.
L
For example,
stores the
one
list of
shop, only
distinct
one
shops.
category of items must have been bought. Like the shops must be different, and each shop there can be multiple items, but from this one particular category.
Only one category, right? Distinct
Yes, sir.
shop with only one
Yes, sir.
category.
Yes, sir. Distinct shops.
Yeah. So what it is doing, X dot shop shop name, it is passing the shop name to the dictionary.
Yes, sir.
It is checking whether the shop name is present in the dictionary or not. If it is not present, then we are updating the dictionary. How we are updating the dictionary? So we are looking at for each z in y dot item list, if not member, the z dot category. In shop name, you have category.
Yes, sir. Like the category of items purchased, for example, vegetables, fruits. I think it's like that.
So what about this x? Should it pass the x or should it pass? Okay, because you are passing the card basically, right?
Yes.
In this scenario, if x dot shop name is not a part, it is passing the card detail entirety.
Okay, sir. So if the procedure update DFI, it passes the category of the shop name, like the unique category. If it is not a member, then the category is included in the shop name.
Category is included in shop name? No, shopping bills data set has separate, right? Okay, still. Any of the shopping bills. If you pass the full card, right, you will have that category information. X dot category is always available.
Yes.
X dot item, X dot category. Sorry. What was it? Incorrect conditional statement for both 21 and 21. It makes sense. Not member, it doesn't make sense. It should be is key. At the end of the execution, L stores the list of listing shop from only one category of item those have been bought.
So I think I'll try to find it out myself.
Okay. L stores the listing shop names. Not necessarily the dictionary A has to have that information. Anyways, work it out. I think I'll just stop for today. If at all required, I'll ask them to conduct extra live sessions. Okay. Pretty late. Thank you.
Question is remaining.
Sorry. Yeah. What your question was?
So graded assignment week 10. That question number 9.
Yeah. No, I'll get back to you. Okay. I don't think I will be able to cover it today.
So will there be another session, sir?
I'll ask. I think I will ask them to post it also. I'm not very sure.
But can you just have it, sir?
Yeah. I'll ask them. One more session you want to have?
Similarly, can you ask the other subjects also, so that we can finally finish our questions?
When do you want to have extra live session?
Today only, sir, because tomorrow is our exam.
Today is very difficult, I think, because it has already been scheduled. It's better to practice in that way. Okay.
So at least could you just ask them, sir, maybe from 8 to 10 or something?
I'll ask, okay. I'll ask them if it is possible. I'll ask them to schedule. Okay. 8 to 10 or maybe after 9.
Yes, sir, that's also.
Okay. Have a good night. Bye.
Yes.
Thank you, sir.
Thank you, sir. But at least CT session, can you have one after 10 or something?
Yeah, I'll ask whether they are able to take it. Some other instructor. Okay.
Okay, sir.
Yeah, sure. Thank you.
Thank you, sir.
Thank you, sir. Good night, sir.